I'll be here. I need more space. Good morning, everybody, and thank you for being here. We have a technical session to talk about coastal vulnerability. We're going to be passing to you the existing guidelines that we have. We are also sharing with you a copy of the PowerPoint. I want to acknowledge that we have our city mayor, Marianne Riggins, here, and our Mayor Pro Tem, Bruce Silverstein, here also. We have our geotechnical staff, contract services, our public works staff, and I will share the microphone with all of you so you can introduce yourself. I also want to acknowledge that we have representatives from the Structural Engineers Association this morning. So are we waiting for anybody else? Mike, would you like to sit on the table? And then we have other engineers that are joining us through Zoom. We will acknowledge them and see who is in Zoom. So the meeting for this morning on coastal guidelines, our agenda will be introduced. I'm going to pass the microphone so you can introduce yourself briefly, and then we will have a presentation by our coastal engineers or consultants. It will take about 15 minutes, and then I will pass the microphone around the table for our coastal engineers that are here present to give their feedback. I also receive a presentation from some of you that you will be presenting. So we can have you give enough time for your presentation. We're giving 5 minutes to each one of you afterwards, and then we will pass the microphone to for discussion and for questions to our city mayor and our Mayor Pro Tem. So with that, I will pass the microphone for Mayor.
Marianne Riggins, City of Malibu, Mayor.
Bruce Silverstein, I guess Mayor Pro Tem.
Lauren Doyle, Cotton Shires, Coastal Engineering Consultant.
Mike Phipps, Cotton Shires and Associates. I'm an engineering geologist, coastal engineering consultant.
Good morning, Tatiana Holden, Assistant Public Works Director.
Good morning, Jorge Rubalcava, Senior Civil Engineer, Public Works.
Good morning, Brian Chushinsky, M&S Engineering. I am the floodplain management consultant for the city.
Good morning, Larbi Azaz, Planning Division.
Joe Tootle with NGO Incorporated.
Paula Logan, fire victim, lady who built her bulkhead in 1983, planning to rebuild it again, hopefully at a reasonable cost and in a reasonable engineering.
Reg Brown, Coastal Engineer from Pacific Engineering Group.
Janelle Lau, Coastal Engineer for Moana Engineering and David Weiss.
Dave Weiss, Structural Engineer and Coastal Engineer, David Weiss, Structural Engineer Associates.
Tom Moorhoff, I'm with TY Lane, I'm also a structural engineer.
Marty Hudson with Hudson Geotechnical.
I'm Garrett Mills with TNS Structural and representing Structural Engineers Association of California today as past president.
Michael Cochran, Structural Engineer with Thornton Tomasetti.
Ricardo Roland, Structural Engineer, also with CIOSC.
Thank you. And then Lindsay, could you please share the microphone to see who is attending via Zoom?
Yes, we have Dave Skelly from Geosoils and Dylan Anspatch from NGO. We also have a guest named Stephanie online.
With that, I will pass the microphone to Lauren Doyle. She will start the presentation this morning.
You. Whoops, there we go. We appreciate your being here today. I can't see the presentation, so I'm not sure I'm supposed to do this. That's okay. They just popped it up there. I mean, I have a copy here. We appreciate your all being here today. This is not the beginning of the conversations that we've had with everybody, but I'm hoping it's the cumulative sort of recommendations where we can then finally put some of these issues to rest and make recommendations to City Council, which is, I think, the purpose of this meeting. So I'm going to start off, and then Mike's going to pick up. What I really wanted to do was just kind of give some background as to how we got here, what we're here to discuss, and how we got here. So first slide, please. Next. Is there somebody that's handling that? Oh, do you want me to do it? I can do it. Where do I point it? Is there a particular place I need to point, Farah? Okay, it's not working. Okay. So we're really here to talk about regulations and risk for the fire rebuilds on the beachfront, right? Because there have been a bunch of decisions made by the governor, and then there's been some local ordinances introduced. And then there are a lot of design constraints. And we also know that there are budget constraints for people. But ultimately, when the governor waived the Coastal Act, it indirectly eliminated the consideration of sea level rise in the siting of these structures. And elevation of these structures is extremely important to be protective for their long-term use. They're going to be expensive to rebuild, and based on the way the regulations are written for non-fire rebuilds, these sites may be so constrained that once these fire rebuild structures are built, I don't know whether these lots would ever be able to be redeveloped in the future. You know, that's an unknown. So it's about risk evaluation and timeframes. These buildings have to be designed for appropriate timeframes for the future. And what we want to do is get your input, right? So we've talked to many of you individually, but we wanted to formalize that. Next slide. Oh, okay, oops. So when we're looking at a rebuild, this is really what we're talking about, right? This is a idealization of a structure section. You can't really see, it's hard to see the beach there, but these are basically all the key elevations and points that have to be discussed for beachfront projects. Breaking wave elevations for the front of the structure, the FEMA base flood elevation, protection for the on-site wastewater treatment system, where the structure is relative to not only the base flood elevation, but also PCH for access. So for the Palisades fire, when we look at where Malibu is and what's happening with its shoreline, it used to be that LA County was responsible for gathering all that data and providing that description, right, of what's going on with the coastline. Since that time, it's been taken over. Since Malibu Incorporated, really the Corps of Engineers has carried on that mission along with LA County, although LA County still is more now concerned with the public beaches and not the private beaches. The last real snapshot we have of the entire coastline of Malibu, and Dave, Reg, correct me if I'm wrong, I think is the Moffett and Nickel 1994 coastal erosion study. That's the last complete snapshot we have of the Malibu coastline. The eastern Malibu beaches are characterized by being narrow, and the lack of sediment exacerbates this. Carbon and La Costa have sandy beaches part of the time, in part because material still does come down Malibu Creek, right? But as you move further east, Las Flores, Big Rock, and Las Tunas are all wet beaches. And that, I think, is in part because there is a lot of sediment locked up behind Ringe Dam, but also, too, it's very episodic, right? When we have heavy storms and El Nino years, and a lot of sediment gets washed out, then sand tends to accumulate on the beaches. And when we've been through extended droughts like we've been, I'd say in the last 2 decades, I think that's a fair characterization, then we don't have as much sand on the beaches. All of these beaches are backed by coastal armor, every single one of them, right up to PCH with seawalls. For the fire, we kind of are alone in this. The city is alone in having to make these determinations for fire rebuilds on the beachfront, because the County of Los Angeles lost 0 residential structures, and there's a few commercial structures that were damaged, but no residential. And we have 330 on the beach. So Coastal Frontiers has been doing some work down for the County of Los Angeles. This is from their most recent study on beach restoration projects that they're planning on doing the public beaches. And this basically describes the sediment cells, and it shows the location of these fire rebuilds relative to the sediment cell that feeds the beaches on our section within Santa Monica Bay, east of Point Dume. And limited sediment supply means wet beaches. We have some significant underlying issues. The shoreline conditions do vary by beach, so there's no one size fits all, right? We have 4.5 miles of slightly different coastline and different geological conditions and bedrock conditions. The hazards are likely to increase in frequency and magnitude. That is shared by everybody. The hazards cannot be entirely avoided, right? We don't have any place to move these houses laterally. They can only move up vertically. And if they cannot be entirely avoided, then you've got to mitigate. And the other unique situation is we have on-site wastewater treatment systems, and those have to be protected for a reasonable time frame with shoreline protection. And unfortunately, that is driving a big chunk of the cost of these rebuilds. It's not just the foundations, but it's the seawalls that have to protect these systems. The regular CDP regulations prevented really new structures and major remodels on the east side. I think that's why we saw a lot of older structures. There was a lot of bootleg repairs, a lot of remodels, but all under the threshold of what would take a CDP. And so this resulted in the pre-fire finished floor elevation of a lot of these structures were actually low, right? Too low. And some of them have to be raised up significantly. So this is just, I wanted to show this graphic. Not all the PCH elevations are perfect, particularly in the east end, but this shows from Carbon Beach down to Las Tunas Beach. The blue line is the FEMA floodplain elevation. This is an NAVD 88. And then the orange line is the relative location of PCH elevation-wise. I also wanted to talk a little bit about the wet beaches and meteorological events and how, even, and I'm not talking about major events like the big storms of 83 and 88. I'm talking about kind of everyday stuff that we see. So we're going to use 2017 as an example. I picked out 2 events. One was king tide, and then because we actually have good Google photos for the king tide, and then a south swell event that occurred on 10/8. The wave heights weren't particularly high, but we have some good photos of what that looks like on Big Rock Beach. So here is the south swell on October 8th. The wave heights from the Santa Monica station weren't particularly that high, somewhere around 4 feet. That's actually kind of in line with one of the lower waves that gets used in the coastal engineering design. It's a longer period, shorter, smaller wave. I don't know what time this picture was taken, but the tides were not, the highest tide that day was 6.2 feet. So not particularly too high, but really kind of along the lines of what gets used in the design for wave uprush. And so when you look at it, the waves break fairly close and they come up pretty close and splash up under these houses, right? So this is what not a very extreme event looks like. It just happens to be waves focused from the south. This shows what the king tide. I don't know, Farah, if you can. That should be a video that popped in there. Sure. Yes. Oh, sorry. It's 10:8:17. Did I mark it wrong? My bad. Apologies. I did the best I could with catching all the edits. Right. Is that video embedded? Okay. Well, there's a video. If you just choose to do a Google fly-through on December 5th of 2017, you just do the little Wayback thing on Google Earth. You can fly along the beaches of eastern Malibu, and they are all wet. Okay. This is a king tide. It's not even the most extreme of the king tides. This was taken on December 5th. This is the high tide event at it was, I think, 6.89 feet. But the water is right up to every single coastal protection along the entire eastern stretch of Malibu. Okay. So again, a typical event that we see twice a year at least. Right? High tides, king tides, and sometimes more often. When we were speaking on August 27th, there were some questions about datums and elevations. So we just thought we would throw in kind of a typical beachfront design, kind of a generic section, right? That talks about where the various elevations are. And this is more for just people's edification, right? But also to note, the FEMA base flood elevations are based on wave uprush, but no sea level rise, right? Sea level rise pushes the elevations up, and currently the BFEs do not include a climate factor change. This is just this is a local from Santa Monica. I put this in there just so people would have a reference for datums. And then here's how the datums affect boundaries, right? And the governor's order waiving the Coastal Act basically removes the imposition of these boundaries laterally on the fire rebuilds. That's the main point to note from that. Here's an example of how those boundaries are determined. They go out and do surveys, and then if you were to do a regular CDP and not a fire rebuild, you would have to set back from the most landward mean high tide line by 10 feet. And then that would be the area that you could develop. So as you can see, this is a stretch on Big Rock. I think this is where Caltrans is putting in their secant pile wall to protect the edge of the coastline there. This is from the Trans Systems report. So the current coastal engineering guidelines in general for wave uprush evaluation, those are based on Army Corps and LA County data and practice, okay? So the Army Corps developed the methodologies as noted in the Shoreline Protection Manual and the Coastal Engineering Manual, and there are wave uprush study standards, and those are in our regular coastal engineering guidelines, okay? The Los Angeles County Coastal Engineering Department, which doesn't exist anymore, kind of got folded into beaches and harbors. They used to gather LA County coastal data and storm damage observations on a systematically regular basis. They develop local design parameters and assumptions. They have beach profiles every 500 feet. And they provided a baseline data set for consistency of evaluation. Then there are the variations that we've talked about, beach by beach, right, which consist of, where the bedrock is, the soil profile, the grain size, the actual beach profile in that location, et cetera. And this data is available, but it's not all centrally pulled together in any one location. But you can find it as you go through the city's records. And these factors and these data that county used to use is the basis for the new studies too, right? This is taken from Coastal Frontiers 2025 study, in which they're looking at the wave windows, the wave exposure, they're evaluating the grain size, and they've gathered up all the beach profiles, and they've taken new beach profiles along existing transects. So they can see that, I think, represents there about if you find that report that's readily available online, you can see over a period of about 30 years, I think, that shows all the beach profiles there. This is Zuma Beach, sorry. That's Zuma. They're looking at the Zuma, Dockweiler, Will Rogers, and Redondo, but I chose the one that I thought was applicable. So this is how we've gotten to where we are. These are the factors we need to consider. This is the state of practice. And now I'm going to pass it over to Mike to talk about codes.
Thank you, Lauren. So when we met a couple weeks ago in a special city council meeting, Mayor Pro Tem Silverstein had specific questions about what are the state and federal statutes that might govern things like sea level rise. Statutes, not statues. So federally, FEMA defines coastal high hazard zone, and all of these properties along the Malibu coast are going to fall into the coastal high hazard zone. FEMA regulations require that you establish base flood elevation plus 1 foot for your local, lowest horizontal structural member. The FEMA guidelines kick the decision down to local jurisdictions whether to include sea level rise. And I'll show you a graphic of that in a minute. We understand there is new guidance from FEMA for climate change modifications to the base flood elevation based on 2016 methodologies. And my understanding is that those have been implemented for, required to be implemented for sort of higher level infrastructure projects, but we haven't seen an application of this for residential development. Okay.
Right.
You want to cover it now?
That we got from, I'm sorry, I know you're going through it, but I want to make sure that we are staying factual by everything that we have. I got an email this morning from the Federal Emergency Management Agency. Their engineer is stating regarding the September 2024 guidelines in FEMA. So I'm just going to be reading their response. On January 20, 2025, President Trump rescinded the FFRMS in an Executive Order 1414A, initiated rescission of harmful executive orders and actions, and the guidance is no longer in use. In determining whether a proposed action for federal funding is in the floodplain, FEMA will be using a 1% annual chance for 100 years. Floodplain and flood elevation for non-critical actions, and a 0.2% annual chance for 500 years floodplain and flood elevation for critical actions, such as the construction of fire and police stations and hospitals. So just for the group and for the information. And I'm sorry, I just got that email this morning.
Not applicable to the homes. Is that correct? We're gonna let Public Works is nodding yes.
Okay.
I have a question that may be naive. Does this necessarily apply to a rebuild as opposed to a new build? I mean, is it?
No distinction.
It's beyond question. Like, no good lawyer can make an argument that this does not apply to a rebuild that was destroyed by a fire. I'd like to understand that because that's relevant to my analysis.
The answer is it applies to all rebuild and new construction.
So our hands are absolutely tied. This is the minimum that we are mandated to live with.
Correct.
Okay. Thank you.
The FEMA regulations state that if you have an existing structure, existing house, and it was built before the first maps came to Malibu, okay, they call that pre-firm flood insurance rate map. If that structure is damaged, okay, in terms of if they rebuild, it's called substantial improvement, and if the cost of construction and everything is 50% or greater than the value of the house, real estate, then the whole house has to be redesigned and rebuilt. So I know it's complicated, but basically there's a time frame as to when the house was first constructed versus when you joined the National Flood Insurance Program. But to answer your question, it's applicable to all.
Okay, no, I appreciate that because this is important to me that everyone understand our hands are tied. This is going to be the absolute minimum that we are permitted to require. Okay.
How do we get the presentation back up? There we go. Okay, so we covered federal, moving on to state level, just to give you the framework. The California Building Code, currently we're operating under the 2022 CBC, which the City of Malibu adopts. There are a number of coastal design provisions in Chapter 16 that are structural. And then Appendix G of that code covers flood-proof construction. That section refers to both FEMA guidance and ASCE 24. ASCE 24 in its current form does not include any provisions for sea level rise, but the new version that will be adopted in the building code next year, which I understand will not apply to these fire rebuilds, does have provisions for climate change. Then there's the California Coastal Act. Normally when we're reviewing projects in Malibu, the projects fall under the local coastal program, local implementation plan. The governor suspended the California Coastal Act, but for a regular project in Malibu, we are requiring wave uprush to be evaluated using 2024 sea level rise guidance from the state of California. For a regular CDP project, projects are restricted by State Lands Commission setback 10 feet behind the mean high tide line, and consultants are required to at least analyze 6.4 feet and maybe even 8.8 feet, which is the extreme sea level rise, in order to guide design. It doesn't mean that they would design for those levels of sea level rise, but we need to understand what can happen, and that's why we are typically requiring multiple sea level rise scenarios to be evaluated. Yeah. Yes, the city adopts Title 26 of the County Building Code and then amends it, modifies it slightly here and there.
Reminding everybody, if you have a question, make sure we have a microphone. This is being recorded. We want to make sure that everybody gets to hear that questions.
Well, my question was, Mike had said that the California Building Code was the code, but LA County Building Code in some instances is more conservative. So I was just trying to get a clarification on that.
Yeah, so the county adopts the CBC under their Title 26, and then the city adopts the county code and makes its own amendments to it. So drilling down into what ASC 24 says, that's the flood resistant design and construction. It is a reference standard in the 2022 CBC. And really what it does is it defers to local communities as to whether design flood elevations should be increased. And I put a paragraph in there that came directly out of the FEMA manual. And therein they mention, local community may elect to adopt flood elevations that are higher than those determined by FEMA. Such higher flood elevations may be adopted for a number of reasons. For example, to show future conditions. For example, predicted upland development, subsidence, or sea level rise. So that's the only mention of sea level rise that we see in the state code. For beachfront on-site wastewater treatment systems, the local agency management plan requires advanced OWTS to be built on the beach. We understand this is still the case based on an email received April 24th from the Regional Water Quality Control Board. And once that was known, that this is where the push for maybe a new sewer along PCH started pretty quickly. Malibu Municipal Codes sections cover requirements for shoreline protection devices for all on-site wastewater treatment systems. And in there it is implied that that sea level rise should be considered as part of that evaluation. For new on-site wastewater systems, all system components shall be protected from tidal and wave uprush action. We believe that the standard of practice in doing that should include some level of sea level rise. So the state level sea level rise guidance, which was the Ocean Protection Council document that came out in 2024, this is the chart for the Santa Monica tide gauge. The chart for the LA Harbor tide gauge looks very similar to this, but this shows you a breakdown by year and the anticipated sea level rise for different scenarios. I've highlighted the intermediate and the intermediate high scenarios, which show 2.9 and 4.6 feet at the year 2100, which is 75 years from now. If we go out to 100 years, it's going to be between the 2120 and the 2130 values, and we'd be looking at something more like 4.4 feet and 6.5 feet of sea level rise to be evaluated. The baseline for all of these numbers came from the year 2000, so we're already 25 years in, and the actual sea level rise that we have measured at the Santa Monica tide gauge as well as LA has been about 0.13 feet. So we're actually below the low scenario that was projected here. The sea level rise policy guidance has a few kind of poignant statements that I pulled out. One of those is that most residential development will fall into the medium to high risk aversion category, and that those projects should be resilient to the intermediate to high scenario when feasible. So this is why we put the 4.5 feet into the guidelines for the fire rebuilds. Evaluation of multiple scenarios using intermediate, intermediate high, and high is recommended in order to inform appropriate advanced sea level rise planning and project decisions. And that leads me to think understanding Malibu's adaptive capacity to sea level rise is really important. I don't think we're looking at what happens in the next 30 years. I think what we're more concerned about is what happens 50 to 70 years from now, and understanding how vulnerable is the coastline. Future councils at this city 30, 40 years from now are going to be needing to make decisions about being able to adapt to rising sea level rise if it's happening as projected some of these scenarios. The point is that we're here today because we want to emphasize that we're not just designing for today's conditions, we're designing for the future. The goal of all of that is to reduce coastal storm damage. Yeah, thank you, Reg. These pictures were from you, showing a deck before and after major storm event. Here's another one on La Costa Beach that was in the historic 1988 storm event, showing waves crashing on the building, and then what the beach looked like 1 month later when the sand had all come back. Yeah.
The picture on the left, how low was the sand? How much sand came back, I guess, is my question.
Okay, yeah, I took this picture in 1988. This is the west end of La Costa Beach. The sand had dropped down. The house that I'm on the deck that I'm standing on, actually the garage of the house that I was standing on taking this picture actually fell into the ocean because it was not on piles. So the sand had dropped down to probably, I would say, 12 feet below where it is in the right picture, allowing these waves to come in on a higher tide. Obviously, I couldn't get out there to measure on that particular day, but it was an extreme erosional event or storm scour event. It's important to realize that that sand that was on the beach just went right off and formed a sandbar. 2 weeks later or a month later, when I took that second picture, all that sand had moved back.
Yeah, thank you.
Okay, so some considerations for setting coastal engineering standards with these fire rebuilds. What we've been telling all of the applicants in our meetings down at the Fire Rebuild Center is really the beachfront design process should start with the OWTS location and understand what is the height of the shoreline protection device required to protect it, because it is typically located under the structure. And so that's going to govern potentially, most likely where that finished floor elevation needs to be if you need a relatively high seawall. Evaluating wave exposure, breaking wave location, and breaking wave elevation at the south edge of the structure is a critical consideration. Also, the elevation of Pacific Coast Highway and the finished floor elevation relative to base flood elevation and wave run-up elevations. This is where that slide that Lauren showed comes in, because in some areas the BFE is actually several feet above the elevation of PCH, and that's creating issues in terms of buildings needing to be raised, and then that creates issues with people's views getting blocked, et cetera. So it's there's a number of factors. This is again the sample section that Lauren had put up earlier, showing a typical beachfront construction, elevated finished floor elevation, at least 1 foot above the base flood elevation.
Important to note that this is an actual rebuild, and these are real elevations.
So we consider that the standard of practice is to consider sea level rise for finished floor elevation determination for any beachfront residence. There are questions about what the project life should be for a fire rebuild. The typical standard in the city of Malibu and the county of LA is 100 years. That's what's in the local coastal program. When we see appeals come from the California Coastal Commission, they're always referencing 75 years, and we don't really understand why that is, because the LCP is 100-year based. The building codes, the FEMA regulations are all referenced to 100 years.
Is the seawall and the seawall and the septic system, do they have the same life of 100 years as well?
That's a good question. I wanted to talk a little bit about probabilities and what happens with coastal engineering analyses, because there are a number of input variables for wave uprush. Each one of those variables has its own return period or exceedance probability. And when you start adding those things up, you can end up compounding the probabilities and creating some excess conservatism, because there's a very small probability that all those variables would be extreme at the exact same time. And so this needs to be taken into consideration with regard to policy setting, because we don't want to, you're not going to be designing for the absolute highest water level that ever occurred, and the absolute worst storm that ever occurred, and the absolute worst waves and wind, et cetera. You would end up designing for something that has a return period in the tens of thousands of years. But we think it's important that, past storm events and the repair history of beachfront properties should be reviewed. And I think that's where a lot of the experience of the local coastal engineers who have been practicing here for 40 or 50 years comes into play. And we definitely want to hear from you about what those events have been and the risk associated with them. So the biggest issues are the on-site wastewater treatment systems, the cost of building new seawalls, and elevating your finished floor elevation. There may be planning restrictions on the height of a replacement seawall that will actually be allowed on the site. So that's one variable. Another issue is maintaining consistency on a certain stretch of beach. With the height of seawalls, you don't want to have one site with a wall that's 4 feet higher than the one next door, because there's potential for overtopping and flanking. There's a need for prescriptive design parameters for consistent wave run-up analysis. Those would include things like how much beach scour to use, what still water level to use, including sea level rise. There's a question of, what is the acceptable risk now? What will the risks be in the future? And can it be demonstrated that a project that might be designed for a lower level of sea level rise can be adapted in the future, or should all of that be mitigated now in the design? So this is one of the kind of questions why we're here at this roundtable today. In terms of future adaptation, there are site-specific strategies that we've seen employed, something like a wave deflector on a seawall, raising the height of the seawall, and then there's regional or community level strategies that may need to be deployed in the future. Particularly on this eastern stretch of beach, it's sediment starved. The beaches are constantly wet, and it's a very good candidate for something like beach nourishment and widening that beach. We think that design decisions that are made on an individual project are going to be best informed by the consultants evaluating multiple sea level rise scenarios and then choosing what's going to be best and feasible for the design. I'm going to pass this back on to Lauren now.
So I'm going to be real quick here, because this is going to end up being what we discussed today is going to end up going back into recommendations to City Council for their consideration. But we've identified sort of 3 basic options. Option 1 is currently what we're using, and these are all for determining finished floor elevation, right? Right now, the bare minimum as required is FEMA BFE +1 for the lowest horizontal structural member, for the bottom, and that everything flows from there. Option 2, would the local jurisdiction consider adding a sea level rise factor to the FEMA BFE. That is not our jurisdiction, but that's something for the city to consider. Option 3 would be modify the fire rebuild zoning ordinance, because when the ordinance was adopted, it specifically eliminated consideration of wave uprush studies in determining finished floor elevation. So there could be, that could be added back into the determination of finished floor elevation. Sometimes it makes a difference, sometimes it doesn't. I've seen wave uprush studies already for some fire rebuilds where it doesn't make a difference, right? The existing elevation or FEMA BFE +1 handles it fine, but not in all cases, right? And then in that case, if they were to choose to do that, then you can look at the risk levels, you know, what sea level rise.
Confirmation of something? I just want to make sure, because it's not stated in here, but I think it's implicit. All of what we're talking about now applies only if it's a like for like rebuild, because the Coastal Act's not otherwise eliminated, right?
We have one CDP PF, and that is a good question. I have to talk to planning about that.
I can't imagine how you
Exactly.
get around the Coastal Act otherwise.
Exactly. I don't see how, if it's a CDP, it means that the CDP applies. The PF modification just means it's related to the fire.
So just to clarify, everything we're talking about is with respect to a like for like rebuild, what
Correct.
the city council should do. It does not apply to something bigger or grander.
Correct. Correct. So again, whoops, we ended up with that typical section again, but that's really what we're looking at. Oops, am I going back? Sorry, going backwards. Okay, so here are the design issues to date that we've been asked about. We've been requested to specify presumptive design parameters. I don't know that we want to do that, but that's something that's open for discussion. There are a couple properties that are on the beach that are outside the FEMA flood zone. I've got one right now. And so what should govern that finished floor elevation? Should it be wave uprush? Or because it's a PV, is consideration of wave uprush entirely eliminated? Should the limits on raising existing seawalls in terms of 10% be relaxed in order to help people rebuild? And in particular, I think this applies to Los Flores Beach, where they've got an existing seawall that might be able to be refurbished and raised some, right? Shared seawalls, agreements permitting, that's something that hasn't been entirely untangled yet. That saves people on the cost of return walls, and given the cost of seawalls per linear foot that I've been told, that could be significant. Limits on raising the finished floor elevation more than the absolute minimum. Okay, if you need to raise it more than the absolute minimum for making your entrance on and off PCH, et cetera, you know, and you're still within the height restrictions, can you do that? That's a planning question. And for some parcels, FEMA BFE is well above PCH. We've got about 13 that are identified, and we have put that in the hands of Public Works to address with the applicants, because that's going to be the driving force for them.
Explain what it means. Maybe everyone else understands it already, but to have to raise your structure above the FEMA +1 for other reasons, because I don't get that.
Access reasons, sometimes you end up with like a split entrance in terms of the garage.
Maybe someone else can explain it. I mean, I don't understand why you'd have to raise your.
Oh, okay.
base.
Well, I'm sorry, and I should have said the other reason is if your wave uprush shows that your seawall needs to be higher, and that's going to impact the bottom of your lowest horizontal structural member, and that ends up being higher, makes your finished floor elevation higher than the FEMA BFE. We've had one case where that's been the case, where they've needed to raise the finished floor higher than what would be required by FEMA because of the wave uprush study and the location and height of the protective structure required for the on-site wastewater treatment system.
Okay, I have some questions about that, but I can explore that later.
So in the leach field area, you also have a minimum distance of leach field that you need from groundwater. So your thickness of your layer of leach field might actually push your structure up because you need clearance from the top of the leach field to the bottom of the structure as well.
Requires 6 foot of clearance from the top of the leach field to the bottom of the structure. All I'm saying is we haven't seen everything there is to see yet, and there may be situations and conditions that develop. And so what do you do in that case? Okay. Do you know, what's the hierarchy of priorities in terms of decision making and allowing people to raise their structures? And the big issue for that is because some of these structures are 3-story structures, right? And so they're going to exceed the planning height limitations that are normally apply, and or they might begin at that point to obstruct people's views behind them. So there's just multiple considerations, and we want to make sure we didn't miss any of those.
Okay, and with that, we also have another presentation by Tom, a structural engineer. We will be sharing that. You're ready for your presentation? Okay, and then we have another presentation, a few slides from another engineer. Would you please say your name? We didn't get to hear you.
Hello, my name is Hamid Bazgirkhur, PhD, coastal engineer from Noble Consultants, and I have only one slide.
Okay, and
it's
then
affirming the information that Lauren has informed to us in the past.
Okay. Would you like?
Of course.
Good morning. I'm Thomas Fischetti from Noble Consultants.
Welcome. So we will, Tom, we'll pass the microphone.
So again, I'm Tom Moorhoff. I'm a structural engineer with TY Land, working on several fire rebuilds in Malibu, some of them. I just want to talk today about the impacts, try to give a tangible example, a case study of the impacts of a lot of what we're talking about. And I want to talk specifically about seawall. I've got a picture on the screen, which some of you will recognize. Thank you. What I want to say about this photo, I could say a lot about it, but it is very quickly, I want to highlight that it's showing 2 generations of seawalls. This was a new seawall going in the early 80s, and that's the one that the bulldozer is excavating in front of, and we have some, I'll say maybe 18 or so. I think Thank you. So new drilled concrete piers, it looks like, with timber lagging going between them, and those are several feet on center. And then just to the right of them in the photo is the darker, smaller diameter, probably timber piles that were from an earlier generation. And the main thing that you're seeing when this went in was what was required was far more significant than what was required previously. And that is a trend that started and is continuing. And what I hope to highlight is that that trend may be linear or maybe more than linear, increasing exponentially. So this is a summary of data. Sorry, it's small. Resist the urge to squint. I'll zoom in. But what we're trying to show here, so we've studied right now 5 sites that are plotted here on 3 charts. Each of the charts, on the vertical axis, you see the required design load, the total magnitude force on the wall for every foot of wall. And then on the horizontal axis, we're varying the sea level rise, and they closely follow the sea level rise numbers that Mike shared earlier. So by showing these 3 charts, the first one on the left is with sort of a minor scour, which is analogous to shallow water in front of the site. And then on the far right is an extreme scour, which is analogous to deep water. And again, by showing 5 sites, varying sea level rise, and varying the water depth in front of the site, you can see the full sort of full spectrum of design load that may be required on a seawall. Now, this seawall is in a particular location out at the front of the site, directly behind that wall we just showed. So that affects this as well. Sorry, last thing I'll say here is the range of forces goes from, I'll say, nominally 0 to 75,000 pounds per linear foot of wall. It's a huge delta. So I zoom in on the moderate scour condition, and I've highlighted the case study that I want to show. And basically, we have done a design, which I'll show you, which is for about 40,000 pounds per foot of wall. If we were in the moderate depth, moderate scour condition on our sites, we would be at the very high end of this chart. If I go to the next chart, where we have a deep scour down to about NAVD 0, I think, we'd be at the low end. And so we would be able to accommodate like a 2.8 foot SLR with this design on these sites, whereas over here we could accommodate a much higher one with the design I'm going to show you.
Go back and, because you said it very quickly, and I want to make sure I understand as we're looking at it, the difference between the two charts. I understand this is the load for 2.8 feet of sea level rise, right?
Yes, and so apologies for going fast. I'm just trying to cram it in here in 5 minutes.
Sure. It's
so
important, though,
it
because
is.
these are the types of issues that we have to think about.
Yeah, and the high variability is what I'm trying to show, so it's important. So again, the three charts, we studied 3 scour conditions. One with sort of minimal scouring down to, I think, plus 10 feet, basically like no scour, I think. The middle one is scouring down to, I believe, plus 5 feet on our sites. And then the right graph is scouring down to the rock, which is at about 0. And so depending on that scour, or if you ignore our sites, if you just say, depending on the depth of the water in front of your site, you will land on one of these charts. And we're going to show a design that could be used on any site, right? And depending on which of these charts you land on, you would be able to accommodate, because it has its inherent capacity, a different sea level rise number. So on this moderate scour condition, if your depth is down to about plus 5, in our case, in our location, that would allow us to have a pretty extreme, or say a high sea level rise number. If we have a deep scour, if we scour to 0, or if you just had deep geological profile in front of your site, you, with the same design I'm going to show you, you still can only achieve that same capacity, and so you would be able to go much further down on this chart. Okay, so 2.8 feet in this case, or something like that. So this is a site plan. It does not show the residential foundation. This is purely a seawall study. And I'm sorry, it's very light on our screen here, but what you would see if you could zoom in is way down at the bottom of the property line, closest to the beach. That's the bottom of the sheet. Sorry, closest to the Pacific Ocean is the bottom of the sheet, is that seawall that I showed in the photo in the beginning. And there's, you know, moderately sized piles, reasonably spaced, going down the beach. And what's required is just up sheet from that, which is a secant pile wall system to achieve that design capacity. The detail sheet, I won't go through it all, but I'll zoom in on a couple. And on the left, it's a plan section. You're showing a primary pile. In our case, we designed it 2 foot in diameter. It goes down 1 foot socketed into rock to achieve an adequate seawall condition. And then in between each of those, what was required for those numbers was a 3 foot diameter, pretty heavily reinforced pile extending quite a ways into the rock. You know, depending on the loading, it might be 10, 20, 30 feet into the rock. So on the right, it's an elevation view of that. So the dash lines are the smaller pile going 1 foot into the rock, and then the solid lines are the deeper primary or structural pile going further into the rock. So just in summary, I want to say, as you I'm sure know, there's a high degree of variability across properties along the beach. This is for one of those wet beaches you described, Lauren, and they will experience disparate or different designs, right? They will have different seawall requirements. But as you slide the scale of sea level rise, this isn't to say what the right number is, but what I have seen in these numbers is that for sites with deeper water in front of them, they will be more adversely affected by that sliding scale of sea level rise. And so they, you know, some of them, depending on the number, may get so significant. I've just shown you a very robust design, I'll say. And some of them may be so robust that they are not really realistic for a homeowner to rebuild.
My comment would just be fully understand that, and fully, this is why we need to be careful about what we're deciding for finished floor elevations, right? And what the standard is for that versus what we're requiring to protect on-site wastewater treatment systems, where the protection seems to be costing 4 to 5 times the cost of what you're protecting, although it's ultimately the actual use of the property that you're talking about, right? Is that a good, succinct description of the problem?
It is, and I just want to say I only focused on seawall because it can be done in a vacuum, but there is a parallel and often very closely tied story to be told. The building foundation, yeah, and so a seawall is a hardened, flat, horizontal structure which takes all of the wave energy. There's nowhere for the water to go. If you don't have that robust seawall and the waves are able to go under the home may only have piles under it. And while they will take significant forces and it will be difficult to achieve, they are not necessarily taking the full brunt of the wave like that seawall I showed you was.
Another question about the way we do the wave uprush analysis, and that is, we should at least explicitly discuss this, is we do that without protection, right? When you're looking at what the forces on the piles are, right? That's the way it gets done. If you know you're going to put a robust wall in front, is then that a reasonable design assumption for the piles?
I think it was a clear question. I may have just lost track of it. But basically, with that very significant seawall, depending on the amount of wave uprush and overtopping that occurs, the building piles behind will certainly take far less load than they would if there was no seawall. But again, it has to do with overtopping and how high your wall is and how much water is going in. There's a complex study there that our coastal consultants would be doing.
Okay, I'm sorry. I need a basic education on this whole thing. I got part of what you're saying, but I think in practical terms, we are contemplating the installation of a sewer. So if in fact that is placed in there and there is no seawall, I know some people have seawalls because of other reasons, but if for some reason there isn't a seawall to protect a septic system, what is the house going to be required to design to make sure their house stays there without that protection? And is that something that the homeowners understand?
I think there are others who can answer that well, I'm sure. I just want to say that in general, if there is no seawall, the design forces on the residential piers or piles is higher, but they are piers and they don't take, again, the full brunt of the force. There is a question about the front wall along PCH. There is a front wall along PCH, a retaining wall, that would, be subject to some heavy load then because it's unprotected now. But it is much further at the beach and presumably takes less load than a seawall way down near the waterline.
Say that again. What? Question I have is, are we talking about the seawalls protecting the structure or protecting the sewage disposal system only? Because my understanding of what we've been doing in the past is we design the houses if there's no protection, and we design the seawall for whatever it has to do to protect the sewage disposal system. In which case, why are we worried about? In other words, we have to go through this 2-cycle design. One for the house with no protection, and the second would be for protection of the sewage disposal system only. Is that what we're getting at here? Okay, that's number one. Number two, how do they figure the scour depth? Erosion. No. Scour from wave action.
So scour is from beach erosion, right? It's from the waves coming in and taking it out. So the example that he gave you, he said 10 feet, 5 and 0, right? So 10, 5, and 0. 10, very rarely, that's like where your beach starts. It's in general, depending on where we are in Malibu, but it's kind of where your beach starts. Typically, we find it to be at about +2 from way long time ago, right? The beach will scour to about plus 2.6, right? That's about 0 mean low or low water. So We're talking elevations from, given whatever your highway reads. So at the numbers that he gave you will only get bigger because the scour is probably going to be more like his third example, which was at 0. More than likely when we do the analyses.
I just want to add to that. We have currently a lot of seawalls at different locations on the beach profile. Current Malibu Municipal Code and also the LCP states that the seawalls and the septic systems have to be as landward as feasible. That's also in the municipal code as well. So we have had in the past seawalls, even wood seawalls that are in front of the structure. The closer you get to the ocean, the deeper you have to go because you get more scour. When you're walking on the beach, you're walking on the flat portion of the beach, then you get to the top of the berm, which is the top of the foreshore slope, and you walk down that sloping portion, which is about, most of Malibu, it's about 1 foot vertical for every 10 foot horizontal. So it goes down to about elevation mean low water, and then it flattens out again. It's that slope, that foreshore slope during seasonal conditions that will move landward in the wintertime and seaward in the summertime. Just the waves putting the sand back on the beach or taking it off. That's the scour, okay, is this oscillation of this foreshore slope, okay? So if you have a seawall and in the summertime, there's only 2 feet of it sticking up above the sand. In the wintertime, the waves pull the sand off the beach and you can have 10 to 12, even some places 15 feet of wall exposed when normally you would have just 2 feet.
I have a question. If you assume that the structure base elevation needs to be FEMA +1 and that's the only requirement, and for whatever reason a specific property is going to need to have a seawall higher than that to protect the wastewater treatment system, does that have to take up the entire elevation of the structure, or is that a portion of the structure where that seawall protecting the OWTS is?
Reg, do you want the structural engineer to answer that question?
So that's a very good question. That's a situation that we come up with time and time again. How we've dealt with it in the past is where we have a seawall underneath that has to be higher than the finished floor elevation. In these rebuilds, it's not going to happen that much for a variety of reasons, the base flood elevation and everything like that. When we use a floor, or when we put a floor above a seawall, and you saw in some of those slides the waves hitting the seawalls and splashing up, what we can do is take into design consideration the splash up forces on that floor, okay? And which includes buoyancy forces. So you have forces due to the splash up, but then also buoyancy forces if that water piles up underneath. It'll tend to want to float momentarily anyway, the house. So what we end up doing is using a concrete structural slab that's heavy enough to resist those forces. Another thing about the wave forces on seawalls, I was looking at the slides there. Does your analysis include the passive resistance of the backfill of the seawall?
Marty, you did give us diagrams. The short answer is yes. We have sort of included not just the rock profile, but the sand that exists on either side of the wall. And if it's all scoured away on the ocean side, we haven't used it, but the passives on the uphill side. It doesn't help much, but it helps.
In the Malibu colony, in the El Nino storms, in the Malibu colony, we've had the sand drop as much as 14, 15 feet. in front of that seawall.
Yeah, I'm still not sure. I'm not sure I heard an answer to my question. You might have answered it and I didn't understand it. But so if the OWTS has to be as close to landward as possible, which I'm assuming in many instances will mean it's further back than the front of than the most seaward portion of the structure. And hypothetically, we're talking about it's going to have to be raised higher than the minimum height that the structure itself can be built, the seawall protecting it. So basically, the way I'm envisioning this is you've got a house that goes out, let's say 100 feet, and the first 50 feet of it needs to have a seawall that's higher than the 50 feet beyond that than the feet that goes beyond that into the sea, which is above the FEMA floodplain. Can the base of the structure still be lower at the seaward portion and have a carve out, so to speak, that comes in to protect the OWTS, which doesn't change the base elevation of the structure. It just takes away a portion of the lowest portion of the structure where the OWTS is.
What we have to consider, though, is when we have a seawall underneath a structure, let's take a look at the septic system behind it first, okay? That septic system leach field has to be 5 feet above of the groundwater table, which is roughly around elevation +5. It varies, but it's at +5 elevation. Okay, so then we need 5 feet above that, so the bottom of the leach field will start at elevation 10. And the leach field's typically 3 feet thick, so there you go, 13, and then maybe 1 foot of sand on above that leach field. Now we need 6 feet of clearance from elevation 14, which is right at the sand level behind the seawall, okay, to the bottom of the structure. So that puts the bottom of the structure at elevation 20. Our seawalls are coming in underneath the houses, not out towards, but underneath the houses. They're coming in at around elevation 19, the top of seawalls. Now we can help the house be lower if we put a recurved top on that seawall, on that concrete seawall. So when the water hits that seawall during a storm, splashes up, it gets deflected back out towards the ocean. So that will also help the situation there. So I don't think I have not come across, with your answer, a minimum finished floor elevation or the bottom of the floor below the top of the seawall. I haven't come across that. Yes, with a concrete slab, I'm sure it could be done if you design that concrete slab for that wave uplifting forces.
You want to add
So
anything?
the other, right, so you could have a situation where your seawall was back closer to PCH, right? It actually has to be as landward as possible, right, by your municipal code. So if you had a property that was sticking out past the seawall, which we have some, you could potentially step down after you get past that seawall, but you still have to stay above your FEMA flood elevation.
Said that. And now the other question is, what about the vertical? Does that have to be the entire width of the property, or can it be a portion of the property?
The vertical height of the seawall?
The OWTS, not the structure.
Right. So the leach field elevation is all the same, right? So your return walls are all going to be at that same height, going back towards PCH, and in many cases, the wave uprush is going all the way back up to PCH. So your return walls will go from the start of your seawall all the way back up to PCH with the same top elevation. The bottom elevation could change because the scour line raises as it goes towards PCH.
The bottom doesn't change the height, right? The bottom just changes how far down it has to go.
Right. The top elevation of the seawalls are all basically the same all the way back to PCH.
Okay. So now my issue is, I assume a 60-foot wide parcel. Does the seawall necessarily have to be 60 feet wide to protect the OWTS, or can it be less than that?
Well, it depends on how wide the septic system is underneath the house. The septic system is based on the number of bedrooms in the house. And so you're given a square footage that you have to work with. Now, per municipal code, that leach field has to be, the seaward edge of that leach field has to be as landward as feasible. So what that's going to do is actually widen that leach field, okay? Well, it can only widen so many feet before you run into the properties on each side, okay? Now, we need a minimum distance from that property, that side property line, to put the leach field to account for the return wall that goes in and any sand clearance between the leach field itself and the return walls for the seawall.
Okay. And is the seawall also protected going from the most seaward portion of it into the land on each side, or is it just a front?
No, it's basically, with these fire rebuilds, we're going to end up boxing in this system. So it won't likely be open on the Pacific Coast highway side. In the past, we've had like a horseshoe-looking seawall.
Because you couldn't leave it open on the sides. Otherwise, if your neighbor doesn't rebuild, it's just open.
Exactly.
Right? Okay, so to get back to my original question is, depending on, there can be and will be structures that even if they have to have a seawall protecting their OWTS, which is higher than their FEMA +1 floodplain for the base of the structure, it will only take up a portion of the home going from PCH out to the sea, and it'll only take a portion of the width of the property as well, so that the home basically will have a box carved out of the bottom closest to PCH, and the rest of it can be lower? Or am I misunderstanding that?
In practical, for all practical purposes, the seawalls, the most landward they can be that we're seeing is basically under the building string line. And so the only portions of the house past that would be a deck. So they pretty much take up the entire footprint of the house from what we're seeing. Mm-hmm.
A lot of the lots are narrow. We have lots that are 20 feet wide, around 20500 PCH. It's very difficult to get a septic system in, and given the clearances that you need from the side property lines, that's going to push that edge of that leach field septic system closer to the ocean.
So you're saying most of the parcels are going to be such that if they're rebuilt like for like and the seawall protecting the OWTS has to be higher than the minimum elevation for the structure, the entire structure is going to have less, we'll have to have a higher elevation without regard to what the requirement for the house is.
Yeah, but
I'm seeing a no over here and a yes over here.
We're not, Bruce, we're not seeing that happen, okay? Because what's driving the finished floor of the house and the bottom of the structure of the house is the wave uprush, the height of the waves underneath the house, because we don't have a seawall for the house. The seawall does not protect the house. So when we design the house itself, we are assuming that the waves go underneath the house and break on those piles and then uprush up to Pacific Coast Highway or slightly below it, or even in some instances across Pacific Coast Highway.
I get that, but isn't that without consideration to whether you do or don't need a seawall for the?
Yeah, we disregard the seawall for the house. But what I'm saying is, you're asking me, can we have a minimum finished floor lower than the seawall? And
I'm not. What I'm saying is, based on what I'm hearing, it sounds like for the most part, because of the size of the lots, if there is a requirement of a seawall for an OWTS, which is higher than FEMA +1, that's going to also be the lowest the entire house can be.
Yes.
Okay.
We want to hear from the other engineers. NGO representative, do you want to? I know you submitted a letter to us a few weeks ago.
Yeah, or can you hear me? Yeah, the some of the loads that Tom was showing earlier, I think, came from some of the analysis we gave him. And so just to give a little background into those elevations, As someone said earlier, elevation 10 is about, kind of where the sand is. It changes seasonally, but relatively no scour. I'll defer to Marty. We relied on some of his exploration for what the profile is out in front of the homes. And so we found that it's not just sand on bedrock, right? There's sand on top of a shingle deposit, gravel, cobble soils, which are a little less, or they're more scour resistant. And that was about at elevation 5, and then the bedrock was about at elevation 0. And so so along Las Flores, where that work was done, there is that existing seawall. And so there is a threshold question of, do you try to break the wave energy or, as much as you can before it gets to the house, and provide protection to the septic system out there at the leading edge of the house, or allow the water to come in under the structure as Reg was describing, right? So I think both approaches are, reasonable from an engineering perspective, but it is, I think, a threshold question on what the design philosophy is going to be. And then, we did present, some thoughts on future planning. Beach or sand nourishment is a way to reduce the scour, right? You keep sand there. So those are all long-term planning things that could help reduce the sea level rise impact over time, as well as even armoring the front of the seawall in that case, replacing the shingle with riprap, something. It's still rock. It's rock for rock. It's just a larger diameter rock, so it's more erosion resistant, which I think starts to get the loads that Tom and the other structural engineers have to deal with down to something that's a little more manageable.
Loud enough voice. Can I ask a couple questions just to the engineers? I'm surmising that the what we're here for is to find out if we're going to have the FEMA +1, or is that still on the table, FEMA +1 and possibly higher? Are we here to decide what the number is for everybody in Malibu? I'd like an answer to that. And then I'd like to say something about my home. I've been there about 45 years. My house, my finished floor, is now 8 feet taller. It's higher. I'm raising my bottom floor 8 feet. For all the time that I've lived there, I've never had any damage to my first floor. It's hard to imagine that we have to add more than the FEMA and 1 foot. I mean, it's speculation. In 45 years, I haven't had any damage. I feel that 8 feet higher gets me at street level, at the proper level, and anything else would be very difficult for a lot of people on the beach. So I'm hoping that we're allowed to have in certain areas the FEMA +1, and if there's some extraneous situations, we have council people who have to vote on this, and it's not a simple answer, and I hope what I'm saying is going to be considered, and I'd love to hear anything from, I have some consensus from the engineer here that we should have that flexibility from FEMA 1 and more, but not just 1 fits all. Thank you for taking my question.
And now that it was supposed to be a discussion for technical, but I appreciate that you're here. I also want to ask Carl, Rondo, and Dean. They have been here part of the meeting. If you want to state anything, we were not anticipated that we were opening to homeowners, but I appreciate you guys coming forward to give everybody a time to voice their concerns or feedback. We're trying to get there.
I'll answer after we hear from the 2 homeowners.
I will be brief. It's basically being said here. Paul is referencing where we are. I'm going to be a minimum 10 feet higher than I was before. If we add SLR, I will then be 20 feet higher than I was before. So I'm very concerned about the loads that Thomas is talking about and what that's going to cost to build the infrastructure. So those are my concerns and why I'm here. Thank you.
Thank you. I'm on Big Rock Beach for everybody to understand my situation and a group of owners that I'm working with closely as well. I'm encouraged by the discussion because it gets the facts out on the table, right? Because I know this is not an easy situation, but the facts kind of speak for themselves, in my opinion, relative to what's on the table today, relative to design specifications, would be my point, right? Aside from that, every homeowner working with their specialists then has to decide what the right solution for them is, right? So please don't do one size fits all. Because if you let us have that toolbox to work with our specialists, then we can best figure out what's right and do the right thing for the city, the right thing for the neighborhood, and hopefully be in a situation where we can manage our costs and time frame and actually rebuild. And that's my viewpoint.
So to follow up on that, multiple times it's been mentioned, don't do a one-size-fits-all. So I'm a little confused by that, because if we just say FEMA +1, isn't that a one-size-fits-all?
It is, so let me clarify. FEMA +1, the reason I'm not concerned about a FEMA +1 one-size-fits-all, because that's the minimum requirement, right? So when we're talking minimum, that's just what it is, right? If we would start to say things like sea level rise should be 2.8 or it should be 4.5, that's unfair, because that's a one-size-fits-all that doesn't take into account any other characteristics that I may have in the toolbox.
I hear what you're saying. To answer first of all, the question, what are we here to do? What are we going to decide? We're not going to decide anything here. The purpose of this is to get information so that the city council, when it makes the decision at a city council meeting, will have the best information. And we're here to gather that information for the city council so that we'll have a little better education at that meeting. I can tell you where I'm coming from listening to everything so far, and I think it's what both you just said. I am in favor of, this is for likes only. This is for fire rebuilds, like for like. This has nothing to do with anyone that wants to build a new structure on the beach somewhere. This has nothing to do with someone who wants to build something more extreme than a like for like plus up to 10%. So make that very clear. They may well have to deal with sea level rise, climate change, what have you. Who knows? But my approach is going to be whatever the federal, state, and county governments impose on us is all I am going to vote to impose on the residents. So if what it all boils down to is the only thing we're obliged to live with is FEMA +1, I'm going to support only FEMA +1. I think going 1 inch above that is paternalistic. It is going to be more expensive. It's going to raise the roof lines of all of these homes that are already over height to begin with and ruin the views. And now the bad news for people is going to be you're not going to get a higher elevation if, because of your property sensitive issues, you have to raise your elevation. Maybe you're going to not be able to build at FEMA +1 because of something special about your property. Don't come say, well, I want an additional 10 feet of elevation at the base, so I get another 10 feet at the top. No, you don't. Unfortunately, your property has lost that height. That's the way I'm going to come out.
Well, and I think to clarify, we established that the homes, you get back what you had. So if you did exceed the current height standard, you get that back. We understand what that's going to mean, though. I would encourage everybody to try and meet current things, but you get what you had back. You don't get to add 10% higher on top of that. And so it's just, we want to make sure that when people, at least my opinion is that when people are driving down Pacific Coast Highway, we already know there's going to be a change in what the look is. The homes are going to be higher because of this. But my whole goal was just to make sure people could get insured and what that minimum height standard was. So I am definitely, I've been FEMA +1 since the beginning. I'm still FEMA +1. And I'm hoping that, everybody will be able to build back as similar as possible. Maybe take a few design changes to jigger some things to make them look a little bit more attractive and maybe take some consideration. But that's where my position is at this time.
Chris, I'd like just to thank you that, and when I said that I'm raised 8 feet, there is a big factor. I'm sorry. There's a big factor between 0 and 8 feet. So don't be so worried about it when you hear about these fantastic numbers. I mean, we've been fine 8 feet lower, and we're happy to oblige to the FEMA +1.
Yeah. So far, what I've heard,
a safety factor. You don't have to be so worried about it.
yeah, from what I've heard so far, I was most interested in learning what is our legal, what are we mandated to do absolutely legally, and I now understand that much better than I did when we had our city council working session. The other thing I'll say though is this is why I was asking all the questions about the seawall for the OWTS. The bad news also for some people is going to be, my view is, if for some reason you're going to be required to have a higher base elevation because of your OWTS and the specifics of your property, again, you're not going to then get to count that elevation as your base elevation for how high you can go. You've lost that space.
Yeah, it's just making sure that when you do design it, there might be some homes that are going to be stepped because the requirements for that 6 feet above your, am I right, 6 feet? Above the top of the leach field?
It has nothing to do with height.
Right, but there may be some properties. Okay.
A one-size-fits-all rule of the minimum is going to mean some people are going to have extraordinary circumstances where they're going to have wanted us to not adopt that rule. They're going to want us to be more flexible, and I'm not going to be inclined to vote that way.
It should also be important to realize that the BFE differs on certain sections of beaches. In the fire-prone area, the lowest BFE I've seen is 17, elevation 17. The highest I've been dealing with so far is elevation 22. So there's a 5. Janelle, have you? Okay, so there's a 27 BFE, so that's a 28 bottom of lowest horizontal structural member. And that's probably where Pacific Coast Highway is at elevation 28 or 30, somewhere out in there.
That section, it's actually around 21 to 25.
Right. So at my particular client's property, the street is at 21.9 and the base flood elevation is at 27. So I have a big problem. It's a 3-story house to begin with, and that 3-story house, the top of the roof will end up being at 44 above the street, right? If they adhere to this base flood elevation.
Let me add just some information that we got from FEMA, because we were able to ask this question from the FEMA engineers, and this is their response. FEMA staff are working with the city's floodplain administrator, which is our public works director, and his team, regarding the elevations difference between BFE at PCH for those 12 beach homes, as well as options for rebuilding in compliance with the city's floodplain regulations. A training session will be held in October by FEMA representatives, and we will follow up with an in-depth discussion to explore the technical details and rebuild options for those 12 properties. So our public works director is already looking into that, and more conversation will be for those 12 properties that have the 28 feet elevation requirement.
I have one question. If I understood correctly, I think what was stated was that there are going to be some homes where there is no FEMA floodplain elevation. Did I understand that correctly?
Correct.
So how, I need to understand more about how we deal with what their elevation is going to be. Is it just, it's just the ground?
I'm sorry. The one property that I have looked at that has submitted a pre-screen and a preliminary coastal uprush study is they are going to be a little bit above FEMA because of the wave uprush, because PCH and the ground surface are all about at the same elevation. In other words, they're down at this very end of the graph here, right? So they have determined their finished floor elevation by their wave uprush.
Okay, but for FEMA purposes, they're the same as any other ground, any property that's not on the beach. And if they want to add a foot of elevation for wave uprush, that's just a foot they're going to lose on their height, right?
I don't set those policies for planning.
And on that specific scenario, Jorge, do you want to talk about this one? Because this is a project that is out of the V zone, it's on the X zone, and the floodplain management group decided that this will not trigger any review from Public Works. Can you elaborate on that?
Yeah, if you're not in the FEMA, if your structure is not in the FEMA floodplain, there is no design that we would impose. That would strictly be done based on what I believe your wave uprush recommends. But in terms of FEMA, you would not be considered in the FEMA flood zone.
Okay, but so what I'm saying is for that property as well as any other like that, my view would be if for design purposes you choose to go up higher than the FEMA, which doesn't exist in your property, because you want to be more conservative, that's your choice to do. But that means that whatever your height restriction is, it's measured from the ground, not from the height you raised it to.
That is correct, yeah.
So finished or natural grade, whichever results in the lower building height.
I just want to interject one thing. Prior to the FEMA flood maps and the firms, the minimum finished floor for any beach house was dictated by the wave uprush study. Okay, and in the condition where the BFE only is considered for that portion of the property that's in the VE zone. On Carbon Beach, that VE zone starts 60 to 70 feet from Pacific Coast Highway. Okay, we do have some houses that are lower than the BFE, but because they're landward of the VE zone. Okay, so that's an important thing. Therefore, the minimum finished floor for a property that is, or a house or a structure that is landward of the VE zone will be based on the wave uprush study, but not the sand level. Okay, because the code says that and this has been from the city of Malibu from day one, that the coastal engineer sets the minimum finished floor elevation based on a wave uprush study. And this was prior to FEMA. But the requirement for a wave uprush study goes all the way back to when Malibu was in the county. Mm-hmm.
The wave uprush study is still required because they're OWTS, and fortunately for them, they have room on the side of the house. It doesn't have to go under the house. This is a wide enough lot that when they rebuild like for like, it will be on the side of the house. And they'll put a higher wall around that above the ground surface. In reality, for this particular house, this means they're only going to lose about a half a foot. So fortunately for them, but it's a question because that's just one house. I don't know every house situation. So the finished floor elevation based on their engineer's recommendations is going to be determined by wave uprush, because if you don't do that, then I don't know that it meets the standard of practice, regardless of what the fire rebuild rules are. And that's part of what I wanted to, throw out there today.
Yeah, that's what I was getting. That's what I was trying to refer to, that in absence of a BFE, you rely, it's a standard of practice to rely on the wave uprush study.
Right, but that has nothing to do with what our legal requirement's going to be. That's just a practical issue you're going to have with that particular property. I also suspect that some of these properties that are going to lose some of their height as a result of having to raise the elevation, even though it's not legally mandated, will have other places where they can get back that space, you know, either going forward onto the beach if they're not beyond their property line, or going sideways. I thought that was only if you're in the water.
No.
Beyond. What about sideways if your property is wider? Okay. All right. Well, there are going to be some people that are going to lose out as a result of that. It's just the way it is.
I was just going to say, to add, I'll answer your question. In terms of the FEMA regulations, if it's outside of your, what they call their coastal high B zone, so the FEMA map shows it as an X, so you're outside the 100-year, okay? What are you required? FEMA will say you don't have to meet the minimum. Of course, it's always better. However, you are still, as a community, National Flood Insurance Program community, you are obligated to ensure that all other local regulations, building code, your general plan, and all state regulations. In this case, Coastal Commission sort of off the stage right now, but one day they're coming back on the stage, you know, at some point in time, okay? And so then those regulations come in place. So for example, let's hypothetically say 15 years from now, rebuilds hopefully completed, or mostly, and somebody is in an X zone outside the 100-year. To say, well, you know, as a council, okay, they can build without having to elevate, you're still required through your staff to make sure that the Coastal Commission, let's say they're reinstated, their requirements are met again. So just keep in mind that is a requirement under Title 44 regulations.
Right, but I mean, the real intent of this is to get people back to where they were before the fire.
You want to get them whole.
Exactly. So we're trying to get them to be able to rebuild a house. Right. Unfortunately, unlike a landside property, there is this requirement. I think I'll speak for Bruce on this and he'll tell me if I'm wrong, but if we could allow people to build back their house where they were before the fire, we would want that. Mm-hmm. The only reason we're even considering this is because we want everybody to be able to be eligible for flood insurance and our city as a whole. So it's just a requirement. But if could be, if the real world was happening, they'd put their house back exactly as it was prior to the fire.
I mean, the insurance is very, very, very important because FEMA is supposed to be updating the flood insurance rate maps every 10 years, just like you're supposed to update your general plan every 10 years. You know, we all get a little bit behind on that. However, they will not, at least under the current administration, refer to climate change or sea level, or like at least climate change, because that's a word that can't be used in FEMA. I just retired from FEMA, so I know that. Okay, I had regular on this. So what happens is this. You're outside the floodplain now. When the new maps are engineered and drawn, FEMA will not use, at least as I'm speaking today, they won't use climate change data. They use absolute certain engineering science, okay? What are the conditions today that we know? Not, and I don't mean to offend, but not a hypothetical climate change model that has not yet been conclusively proven in our country. So what happens, what they do is they'll use data of 2025, and let's say they're doing this in 2040. If there's a difference in the height of water of flooding, it might be climate change, but they're not going to say it's that. They're saying that's the current condition. Where am I going with this for insurance? Today you build the house and you're outside the floodplain on the beach, and you raise it a foot. Okay, that's great. You're okay. In 30 years or 40 years, those maps are redrawn. Instead of it being 18 feet, you're now 23 feet. The house is it's legal non-conforming. It's compliant, but it's not. If you go to sell the house to somebody else, their insurance is going to go skyrocket. It'll be huge. So how do you know today what it's going to be in the future? You don't. I mean, truth is, you really don't. So what's prudent? From a FEMA perspective, higher is better, but as long as you meet the minimum, that's required. And just one more thing I just want to say, there are split zones on the property, just like zoning. You'll see properties and it'll say coastal V, And then the other portion of the front part is an X, it's outside. Here's what FEMA will allow you to do. If you could build the entire house in the X zone, okay? Like not, so you have to do your BFE, so you do your proper study, your land surveying, but you got a big deck, and the deck is attached to the house, and the deck is in the V zone. The whole house is now in the V zone, so you don't attach the deck to the house. You separate it by a couple of inches and you have its own foundation. The deck will just wash away into the ocean. Hopefully, pray to God it doesn't slide over to somebody's house. But theoretically, probabilistically, it won't affect the house that much. That's what people do. So I guess you use your best judgment, but if you say people have an option, if they want to go higher than that, FEMA will say great, and you'll get a better insurance rate, but they're not going to say you can't.
Right. And I think we have kind of expressed that if people do want to change their design, they just have to conform with the height requirements of our planning code in order to do that. So that's where we get a little things. The other thing I want to say is that I think it's really important that the city start working on mitigation measures, things that we can do offshore to help with beach nourishment, with other things that can be done out in the ocean. And that's something I'm going to be really pushing coming through, that we start working on different things that we can do to make sure that we at least stop the erosion of sand from continuing.
Yeah, and I'll echo that. And I also, this whole thing is making me realize that we probably need the sewer more than I had appreciated in the past. That still remains to be seen. But I mean, I really appreciate that conversation just now, because, you know, people need to understand, if we, I keep coming back to this, is for like fire rebuilds. Our ordinary approach in Malibu is to be encouraging resiliency and to have code provisions that will make sure that that occurs. So if there were just 300 open brand new lots on the beach, we would probably be imposing significantly more stringent standards, and we still will, for traditionally vacant properties, or for someone that wants to just build a property. So, but beware. I mean, administrations change. We've seen that now. You could end up having no insurance 5 years from now. Not just more expensive insurance, no insurance, because a future administration could say anyone who didn't build to satisfy sea rise and wave uprush doesn't qualify under our new regulations, irrespective of whether you qualified 4 years ago. Never know.
Just say a couple things which I was surprised about. For the first time, I didn't realize that it was FEMA insurance that would be losing. The maximum is $250,000. I would give up my insurance all day long to have my house at the floor. So it's not a whole bunch of money if you get a flood. I mean, if this is a whole battle about $250 for people who live at the beach is pretty stunning. And there was,
unfortunately, it's been taught to me, is if any one property is allowed to build below that zone, no one qualifies for insurance, and some people do need it and want it.
And I think for us as a city, we need to protect the whole community, and we hear you. Yeah, I just want to make it clear as Paula, this is really critical that FEMA, we keep our partnership with FEMA, and FEMA understand that this is a serious issue for the city, and we are committed to make sure that we comply. This is a recorded session. No, I appreciate it. Let's just move forward. I just want to make sure that it's safe.
Yeah, Yolanda.
I don't want to take away from it, it's just a stunning.
Yes, and you know, we get audited by FEMA. They'll ask us for our elevation certificates. They'll ask us for the elevation certificates based on your design during construction and post-construction to make sure that we are enforcing FEMA guidelines. There's also, you know, the city of Malibu participates in the National Flood Insurance Program, right? If we are found that we're violating and we're not, you know, pushing these guidelines, you know, there could be repercussions from FEMA for us, and there could be. I'll let Brian speak on that a little more, but we don't want to tarnish and jeopardize any type of relationship with FEMA. In the future, if there's any grants available, we may not qualify because we're not in compliance, because we let certain properties build that are not, not meeting today's guidelines. But let me give this to Brian, touch up a little bit on that.
I appreciate Yolanda. You want to move on this, so I'll move quickly off this. When a community is suspended, removed from the National Flood Insurance Program because it is not building in compliance, the communities get audited every 5 or 6 years. I'll be honest with you. I was one who audited you last. Okay, and it was a very good. It was a good audit too, by the way. But if you have non-compliant structures, okay. Oh, sorry. You get non-compliant structures, and you are suspended, and communities do get suspended. What does it mean besides insurance? Okay, first of all, you're not going to get cheap insurance anymore. You're going to go to the private industry now, and you're going to go to Lloyd's of London, and you're going to pay a lot. And then we're not talking about multi-million-dollar. We're talking about everybody in Malibu, on the creeks and on the beach, if you get taken out of the program. That's number one. Number two, you have to get a federally backed loan or mortgage for your house, you have to have flood insurance, or you're not getting your mortgage, and you're not going to get renewed for your mortgage either. So when you're in the National Flood Insurance Program, FEMA, you'll get cheaper insurance, and that's great. But if you're not in the program, now you got to buy expensive insurance through Lloyd's of London just to have a mortgage. So that's a double ding. And the next thing is federal disaster. If you're not in the program, I'm just gonna be frank. There's 5 or 6 communities that are in the program. There's 5 or 6 communities in the program, and you're not. The feds aren't going to exactly ignore you, but they're certainly not going to come to your rescue immediately. They're going to be helping the others as well. And any grants or loans that you want for relief, or grants or loans you want for stormwater management projects or sewer, you're not going to get. So you stay in the program. That's all there's to it.
And
I also want to remind the group that we only have 10 minutes. So let's just keep it going.
Hence, I want to bring it back to this very important question, okay? Because I think what you have is you have a special case on Las Flores, but it covers a lot of homes, and you're trying to build a new seawall there, right? And you are constrained by height due to percentage from a planning perspective. I want to hear more about that and what you're going to recommend, because it sounds like you're telling me if you go with 4.5 feet of sea level rise and you're trying to reconstruct this wall, it's not going to work. Did I get that right?
I think so. It is a special case. There's an existing seawall, and we've talked about, and what I showed you there was really a strengthening. The idea is to strengthen or reconstruct the existing seawall, and to try to do that, without any sort of special variance, and say, hey, we're staying within a 10% rule, things like that. And that's what I was illustrating there was very difficult to achieve. That's really essentially a new wall buttressing the existing one, and we're studying also strengthening the existing one, et cetera. It's a special case. It applies to many houses. If we do strengthen the existing seawall, we would be limited. You mentioned 10%. There's sort of this 10% change rule, and what that means can be discussed. But it may mean that you can increase the height by 10%, or you can increase the volume of concrete by 10%, or something. But you're increasing it by 10%. But it still would not be able to get high enough. Now, this is a seaward seawall, outboard of the buildings. It is not there. I can't speak to the original intent of it, but it isn't as landward as possible in front of the septic system, the on-site wastewater treatment system. And so it is a seawall that can arguably protect the home, and it's a separate structure. And so that's how we've been looking at it. And still, it is not high enough to fully protect the home, even if that is acceptable to allow to protect the home.
Right. I think so. Maybe the question is, we're probably going to have a separate, again, meeting on that specifically. but I want to understand if you're recommending to use a lower sea level rise for evaluating the wave run-up protection for on-site wastewater treatment systems. That's what I'm asking, I guess.
So as the structural engineer, I don't want to dictate what the appropriate sea level rise number is. It was just to give a data point on the impact of it. And Joe, not to put you on the spot, or others who want to speak to it.
All right, I'll take a shot at it. First of all, if we go back to that one slide on the sea level rise, it was the table that was in the Coastal Commission 2024 report. Yes. What is missing in that table? It's a table that shows the intermediate to high conditions, the sea level. What's missing from that is the probabilities that the Coastal Commission associates with those events occurring. So if in our handout, and I'm still trying to find that, so bear with me. Okay, all right. There is no probabilities associated. You have to go and read the text of the report to come up with the probabilities. That one, right there. Okay. So you have the intermediate and the intermediate high. Now, the probability that OPC gives to the intermediate sea level rise occurring, that is, it's going to be met or exceeded, is 5%. That means there's a 95% probability that sea level rise won't get to that number. Now, if you go to the next one, the intermediate high, that probability of it occurring, being met or exceeded, drops way down to 0.1%. That means it's got a 99.9% probability of not occurring. That is humongous. And why are we being forced to at least investigate a scenario that has a 99.9% probability of not happening? My recommendation would be to use the intermediate, which for a 21-26 sea level rise would be at around 4.50 feet. Marianne, Mayor?
Why is the case of the low number not even contemplated? I mean, considering in 25 years, we've only gone to 0.13, which is below what was contemplated to have actually occurred. Why is it the low and the intermediate low aren't even on the table for discussion? When we historically we're already seeing it's not meeting that.
Yeah, I guess there's a couple ways you could look at that. The percentages that Reg just stated are what they've published in a scenario where we get 3 degrees Celsius of temperature increase since the mid 1850s. So there's even different climate change scenarios. So I think the percentages in the current OPC document, I think, are very opaque. As far as it's not as simple as just choosing one probability of exceedance or not. I guess to be clear, what we were recommending is to not use sea level rise relative to the BFE and simply adding that number to the BFE. We did consider it when we were looking at loads for structural engineers to design to. If you're going to design your foundation, your piers, your seawall, whatever it is, to protect a structure that considers some amount of sea level rise for the structural design, but not to add to the base flood elevation. As I think Reg said earlier, you can calculate a load, an uplift load, if there is going to be water underneath the house and your base flood or your finished floor was not above the uprush. I think there's ways to engineer a solution for that. And so that's what we were putting forth. We weren't necessarily saying take your BFE plus 1 feet and then add sea level rise to the top of it. At least that was our take on it. And because the probabilities, you don't want to add relatively rare events on top of each other, If you're looking at loads to design your structure to, then we think it's reasonable to not take a full scour depth elevation and a full sea level rise event and add them on top of each other. You start to get those very rare events where you're just adding low probability on low probability on low probability. And so that was the course that we were trying to track anyway when we were taking a look at some of these. So
I'm confused. Assuming that there's at least one other city council member, and I assume there'll be more, that agree that the only legal requirement for the elevation of the structure will be FEMA +1. Why are we talking about wave uprush and sea level rise and anything like that? Isn't that just a personal choice that a property owner has to make whether they want to raise their home more than they're legally required?
I was asking with respect to the on-site wastewater.
Okay. Now, with respect to that, we have other laws besides for FEMA that are an overlay to us, right? And again, so I'm going to use the same standard. If there is a law from the water district or whoever that requires something more for that, we're stuck with that unless we can get them to adjust it lower. My approach is going to be get you as low as possible for your mandatory base, and then whatever you do above that's your business.
Sorry, Janelle. So, confusing. Are you guys not talking about the height, but you're talking about how you're structurally engineering the home and what considerations you're putting in?
well, that's what I was proposing.
Okay.
I think they're both important considerations, but at least in the discussions I've been in, they often get conflated. And there's the consideration of where to set the finished floor of the home, and I think the FEMA's base flood +1 foot is important as a minimum for lots of different non-engineering reasons. But when you're trying to design the protection for the home from the
effects of the
waves
flood
crashing
water,
and everything else, I think that's a different consideration, and whether you should take a look at some potential sea level rise in relation to the lifespan of the home. I think the building code does point us in that direction, right? ASCE has provided guidelines for structural design and those sorts of things, but this conversation, in my experience so far, oftentimes get confused with where your finished floor elevation is. And I think you need to think about them separately and address them separately is the approach that we were advocating.
Okay, so I'm sorry. Okay.
The third is for the protection of the on-site wastewater treatment system. That is
Yeah.
a third separate
I got
consideration.
that, but let me see if I can just kind of say this in slightly layman's terms here. So the minimum, the California Building Code with the LA County adoption gives you the minimum code standard that a house should be built to. And then, yes. And then a homeowner, along with their technical expert, can choose to build it stronger, more resilient, more able to stand greater forces and increase their probability of surviving some outlying event. Is that what you're kind of talking about? Is just what the requirements and what your recommendation as a professional to your individual client is to design their home to?
If I understood your question correctly, I think the building code is intended to be a minimum. So if you choose to build beyond that, obviously there's no rules against going beyond that. I think as licensed engineers, there is a standard of practice that exists that we're held to, to keep our licensure valid. So it's the same, but it's a little bit different.
For the wall, is there a requirement in the code to design for a minimum level of force for that wall? I don't think so, right?
Okay, so you're talking about the seawalls themselves?
Yes.
Okay. No, there is not a minimum force per se, but there's also a minimum like fluid pressure that they would require on that. If you look at ASCE and those publications,
they spell out, and even the code itself has a section for flood design. Okay, so you have to consider that. One important point that is lost in our discussion here is we've been talking about heights this whole time. Every seawall in Malibu in the last 50 years that has failed has not failed from being overtopped by wave action. It's failed from being undermined. Okay? So it's just as important to get the level of the beach correct for two reasons. If you go too high with your design beach profile, estimating the scour elevation of the beach, if that's too high and the beach actually scours below that, your seawall will get undermined. And even some piles in the past have been undermined where we've had houses on Malibu Cove Colony drop when they're timber piles. Okay? Now, but if you go too low with your design beach profile and force the design consultants to design to that lower thing, that lower elevation, then what happens is what these gentlemen were talking about is your design loads are increasing and you're ending up in the long run putting in more piles than you need to. And each pile right now, I'm hearing costs of $25,000 a pile. If you go too low, you're forcing the structural engineer to put in 2, 3, 4 more piles than he needs to. You just increase that cost $100,000 just for the seawall alone. So that's where the wave uprush study is important. It determines that scour level. Okay, this conversation has been talking about heights, but we also have to talk about depths. No, not in the code, but there's design criteria that the County of Los Angeles adopted in 1983 for that. And the County of Los Angeles uses a statistical analysis of beach profiles to come up with the lowest 1% of beach profiles with a 99% assurance. And they just designate that as the design beach profile. That's the scour. That's where the beach should erode to during a winter storm, such as we've had in the past. And we base that on the mean high tide line data that is available out there in the public, including Google Earth photographs you can get, okay? And you can get a pretty good determination statistically where that design beach profile, scour profile will end up.
So I'm going to probably make Yolanda and Lauren cringe when I say this. But again, if there had been no fire, the homes would be there with exactly what they had. We're not talking now about new homes. We're not talking about voluntary rebuilds. We're talking about the homes that burned and are going to be built back like for like. I have to keep saying that. Why wouldn't the mandatory depth just be whatever it in fact was? And if you want to go deeper again, that's your business. If you're building not deep enough for safety, unfortunately, that's not the problem the law should address when it comes to a fire rebuild. That's only the problem that we have a practical problem here. We've got 300 lost homes, and we have 300, well, probably less than 300 families because a lot of them were empty, but we've got a number of families that need to get back to their homes. We're not going, in my view, any safety requirement we're not mandated to apply, we shouldn't apply. That's your business whether you're going to apply it for your customer, but it shouldn't be the government's obligation to impose it on you. That's the way I'm looking at it.
Yeah, just to speak from that, so in a general building code and code development standpoint, there is a provision, I think it's chapter 404 or something of IBC that was not adopted by the California Building Code. And what that did is said, if you have an event like this in a wildfire, then when you rebuild that structure, it should meet the current code standard. So just if you equate this to any other, we work a lot in seismic resilience. So if we were to say, build it back to the way it was built in 1920 in Altadena, that's a really bad idea for community resilience. So we wouldn't advocate that. From a resiliency standpoint, we want the houses to be built back to the current building code so that when they have the next earthquake, they don't follow 1920 standards. So I would just say that this is pretty much in parallel with that, right? We don't want to be able to say or penalize owners for building back to a community resilience standard of today's building code, and that's what the insurance companies are going to require also.
Yeah, I do understand that. And this is not an easy decision to make, and I don't know where the council will come out on it ultimately. But my view is this is extraordinary, and in an ideal world, every home will be built to the current code. Ideally, every home that falls behind as time goes by would be reinforced to comply with the current code, but we're not dealing with an ideal situation by any means, and I want to just do whatever we need to do to facilitate people having the ability to rebuild. Now, a lot of people are going to choose to deal with, to make their home more resilient. That's their business. I don't want to be paternalistic when it comes to just getting these homes back.
And we go back to dividing this into separate, right? So you have your structure that need to comply with the FEMA base elevation. We're good with that. I think for me, when we're talking about rebuilding, it needs to comply with those minimum requirements for the state of California. And right now, it has been the question of sea level rise and scour depth. And that is the question here. Do we, under the building code, we do not have any specific scour depth that I know. The only standards that we have, and I'm just going out of the statement that Rich Brown just stated, that we're going out of county standards. Is that correct? So I know where you're going, but I want to make sure that everybody understands when they come in with their seawalls, we are going to be reviewing for current code on structural. The only thing that's for the council to decide or for us to move forward is maybe the depth of the scour depth and sea level rise height on shoreline protection devices, which is your seawalls. But other than that, it's not in discussion. It's everything needs to comply with the code, and I believe all of you around the table agree. We need to design to the current standards.
Yolanda, may I add a point to the sea level rise comment, if you don't mind? Sorry, just out of my understanding is that the 1%, as Brian was mentioning, is the probability of happening. It may happen or it may not happen. But I have a point. In the picture that it was shown to your scour in 1980s, am I correct? When was that picture was showing approximately 12 feet of depth of scour was removed, am I correct?
There was approximately 12 feet of scour on
12 feet,
that beach.
Yeah.
But it's also important to realize that every seawall is different. The scour elevation will, if that seawall was 10 feet landward, then you'd only be talking about 11 feet of scour. So it depends on where the seawall is.
I'm satisfied with 10. So right now I have an analysis that shows for 75-year design, it should be scour, right, 10 feet. Right now we are 2025 and we got that 10 to 12 feet in 45 years. So my point is that maybe that 2.9 with a low, if you are relying on a 5%, is not exactly are going to be in a, let's say, a 5 out of 95, 5 in a 100% chance. The table is saying the probability it's happening 1% in 100 years, but we know that with sea level rise, the probability is happening is going to be less than 100 years. It might happen in 95 years, in 88 years. It would not be beyond 100 years. So my conclusion is that I think the 4.5 feet of sea level rise is a good recommendation. what's going to be happening with also without the insurance. And that was a very, very informative point that Brian very kindly mentioned. Right now, I have a group of architects on my tail. They are going and look at all the probable documents. They say, well, we have recorded of sea level rise of less than a feet in the past 30 years. Why is that? If we can make that comment, I'm not saying how we can publish it, but it would be very informative for them. It's not only what's happening right now. In the next 25 years, 30 years, 50 years, 75 years, if you want to sell this house, the new policies needs to also be applicable to the current situation. So I can also explain about different models that I can apply to, but I think 4.5 feet for a 75-year design is a good practice, engineering practice. Thank you.
Okay.
The 4.5 feet of sea level rise for a 75-year design is a good engineering practice.
Okay, so I want to go back to the probability of the sewer being installed, because I think that's really important when we're talking about this. Because if we do have a sewer installed, then there's no, by and large, there's not going to be seawalls. So you're not going to have to take into account the sea level rise and the scour on a proposed seawall. Okay, so it was more of a statement. So I don't know. I know we have an ad hoc committee on Thursday. I don't know if Tatiana or Jorge have any newer information that they're able to publicly share on that. But I mean, it's looking like it's a strong possibility that it is going to occur. So just putting that out there as you're working with your clients and you're designing as a thing.
Okay, so Yolanda, this question for you. Is it the case that on the depth issue, there's going to be a range of reasonable depth, like there'll be a minimum and a maximum range, or is it a very specific scientific calculation?
I don't know how to answer that question.
Anyone that can answer that?
Can I bring it back to what the timing is of the sea level rise? So right now we're talking about 2100, which is 75 years from now. If you guys are seriously talking about this sewer and we think that this sewer will come back within a reasonable range of the life of a septic system, which is I think 30 years, 30 to 40 years, then why, I think that we should stick to the intermediate, but use that 30 to 40 year range as our sea level rise for our calculation.
Okay. Leave the sewer out of it for now. Just if you're designing a home and you want to make, and you as an engineer want to be satisfied that your seawall is going to withstand the forces,
Sure.
what have you, is there a range of depth that different reasonable engineers could argue is right, or is there a specific number that mathematically comes out for every property based on tests you do?
Nobody knows what that profile is. Nobody knows what that profile is going to be. We can guess, we can yell, we can scream, we can draw all kinds of pictures, but nobody knows what the profile of the beaches can be at any given point. And so we have to use some sort of a methodology. And what we've been doing is we've been saying this: look, find the most landward mean high tide line, and that's why we go through the historical
of record. Yeah, we go through the historical
high tide lines
record.
and every job gets a new survey to find out if there's a mean high tide line more landward than the historical one. Now, once you find that most landward mean high tide line, you drop the beach profile below that, because you're saying, look, we don't know if that's where the most landward mean high tide line has ever been or is reasonably going to be. And the county did some studies many years ago and found that there's a good chance that you can find all your mean high tide lines within an 80-foot swath. Therefore, find your most landward mean high tide line and figure that's the most in the middle. And that beach is going to scour 4 or 5 more feet deeper.
Okay, but you said 4 or 5. Here's my point. Is it a situation where if we take any 5 of you and you get the tests done, you're all going to have the exact same answer, or you're going to have a range of answers which are all reasonable depending on your level of conservatism or lack thereof?
It depends what beach you're at. Depends what the profile.
We're going to pick one property, and 5 of you are going to go look at that property and give me an answer as to what the depth needs to be. Are you going to have the exact same answer within the inch, or are you going to have 5 different answers?
Yeah,
okay.
relatively close, but yeah.
Within a range. Okay,
within
that's
a
what
range,
I assume.
yes.
Within a range.
are we in a position to adopt a policy that would be followed that says that when there's a reasonable range of alternatives, it must be the minimum depth, and that anyone that wants to build deeper is welcome to do that?
Well, I think it's important to recognize, and we've been talking about percentages of occurrence. With sea level rise, we need to talk about percentage of occurrence with scour, okay? And the way I've been doing it is I develop a model that has about 40 mean high tide lines, historical mean high tide lines on this beach. And then I do a statistical analysis showing me what would be, the lowest or the most landward mean high tide line, the most landward 1% of all mean high tide lines. Where would that occur with a 99% confidence level? And that's where I do it. And it's very, very close to what David Weiss was talking about, taking the most landward mean high tide line of record and going 40 feet landward of that, okay? So it's very close. Sometimes it's a little bit farther inland, but not much, okay? So I think the rule should be, if we're going to put a rule on this thing, is to establish the lowest 1% of beach profiles based on a statistical analysis. Unless you intercept bedrock before that. And some beaches we have a higher bedrock, and some beaches like Carbon Beach has got a really low bedrock. And so that's what you're looking at.
Just to clarify, what we're talking about here, not the foundation design. We're not talking about the foundation design of the home in terms of depth, because that's all going to have to go into bedrock because of the geotechnical issues, right? Those will far outweigh any consideration. We're talking about what you're allowed to do or what you should be doing with respect to seawalls in terms of depth. And what the code has to say about that is its standard of practice. The code says a coastal engineering study shall be done, right, in accordance with engineering practice, which is determined by everybody here. And then what we're talking about is adding one more thing to that, adopting a policy of having that lower depth be determined by the lowest 1% of the mean high tide lines.
Yeah, so I think that a good idea would be to adopt a methodology, right, that is accepted, and then have that clearly established for the city.
There is a methodology that's available now. It was started by the County of Los Angeles back in the 70s for this exact application. And it's basically doing the statistical analysis using as many mean high tide lines, given the assumption that the foreshore slope that oscillates landward stays roughly at a 1 in 10 slope with an M equal to 0.1. Okay? That's what we do in it, and that comes out to be pretty consistent with the actual storms that we've been seeing in the last 50 years here in Malibu.
And I appreciate everybody's input. I think for perspective and practicality, and so we can move forward also. If the city is 99% is moving towards a sewer line, can we just discuss within those parameters what is that you guys foresee that the elevation will be for sea level rise for those shoreline protection devices, instead of going back to a 75-year with the 4.6 that all of you feel comfortable? Can we just look at short term, a system that will last 20, 30 years, and that will allow also the city to complete the sewer lines and the connection of it? Because
yeah, what's a reasonable time frame? And also, I mean, now we're getting into a political discussion, which I understand. We have 2 city council members here. So engineers deal with reality, okay? 2 + 2 is 4. Politicians, 2 + 2 is what do you want it to be? Okay?
So
I think I don't want to go into the politics. I think this is a technical, but the city council and the city, in order to establish standards, we need your feedback. So it's not a political question. It's a safe reality. This sewer line is going to happen. And I'm just asking as
Okay,
an engineer also, because at the end of the day, city council is going to look to me and say, what do you recommend we do? So that I need to have that from all of you.
I think you bring up a very good point. I agree. I think a lot of people here on this discussion panel here that we're having agree that if the sewer system is going to be a reality, and by say 40 years, would it be appropriate for the seawall to be designed for that 40-year sea level rise? I would agree with that, okay, but only for the seawall. The house is still going to be there, and so you would have to design the house for the 100-year sea level rise. Now, the house, that would be minimum finished floor elevation, but also importantly, the wave forces on the concrete piles. Okay, that's what we're getting at there too.
An interesting conversation for me, because I had been contemplating that there's either going to be a sewer relatively soon, like within 5 years or so, or there's not going to be one at all. I hadn't thought about 20 years from now there will be one. I think there's a much higher probability that that would occur than that there'd be one in the short term. So I actually like thinking about it in terms of there will be a sewer, but it won't be for 20, 30 years. So that means the bad news is you do have to design an OWTS now. You can't assume you're going to be able to avoid it by a sewer if you hold out a little. But it also gives you the ability to use a lower time frame. I really like that as a compromise, and I would be supportive of pushing to get a sewer in eventually, so long as it doesn't have to be a rush to put it in.
And I think we take advantage of the opportunity to get it put in while the tides and the wind is at our sails to get it through. So, yeah, I want to take a break. I'm sorry. My mind is just going. So I need a little bit of a break so I can process some of this stuff. Yeah.
I don't know of any
Microphone.
bulkheads from my time on that have failed. So I don't think there's a great deal of worry about it. I mean, I built mine in the 80s, and I don't know the old ones when they, weren't permitted properly, but anyone that I know have failed. So I just thought maybe that give you a level of confidence.
We will take a break.
One last word from Dean, and then we'll take a break.
Paula, we're going to let Dean speak right now.
Hello? Yes. So just brief comments. Again, I love what everybody's so spirited about talking about. What I'd like to caution the group about, though, and I'm not an expert. I'm a mechanical engineer. I'm a homeowner. I kind of know what I'm doing. But at the end of the day, some of the facts that are being tossed about here are LCP and Coastal Act numbers. So I caution you, because the experience within our community, right or wrong, is Coastal Act influenced. So that's our experience. That's what we know. What I would ask for, instead of making code decisions on the fly with facts that are being thrown out that might be something different than they're represented as, I'm not saying anybody's doing that on purpose, but just that they could be, that we keep it at the minimum. In other words, all this discussion about scour, it's been left up to the owners with their contractors to come in with something reasonable. So I would say, please don't put new things in place that haven't been in place before. That's what's causing some of the delays that we're experiencing. So I would just ask for your consideration in that regard, because this discussion, not everything that's said is in the light of what you might think it is.
Thanks, Dean. And I will request that we take a break, please.
We'll take a 10 minutes break, and then We'll come back at 11:52, and then we'll wrap it up in 10 minutes because we really need to go into the geotechnical portion of it.
But thank you, everybody, for the great discussions. It's a lot to think about.
Okay, everybody, it's 11:56. We need to come back. Lauren, we need to come back. We need to come back. Bruce, come on. Come on over. This meeting was intended to go from 9 a.m. to 11:30. Well, because we have a second meeting. So we also have a geotechnical meeting right after this. So we also have about 27 geotechnical engineers that have joined online. We have a few of our geotechnical engineers here. Geotechnical engineers, thank you for being here. Geologists, we'll be there with you. And the next 15 minutes, we're wrapping up the coastal session, and then we can start the geotechnical. With that, going back, the conclusions, your structural members needs to comply with AFEMA, be base flood elevation +1. We were in the process of discussing the on-site wastewater treatment system protection devices, the seawalls, and we were there as far as seawall, sea level rise elevations, and that's what we left the discussion. So who would like to start?
Hi. Hi, guys. I would like to start just because I thought we had a really good sidebar right here where we were talking about, okay, the Coastal Commission, Joe Tootle was talking about how the Coastal Commission isn't going to accept anything less than 2.9 feet of sea level rise, the intermediate, right? So there's a couple different things. One is what I heard was it may be reasonable to assume that for a design level for 40 years, for protective devices for on-site wastewater treatment systems, 40 years may be a reasonable time frame. Can we go around and get, what does anybody think? If there's going to be sewers, is 40 years the time frame that you would be looking at for sea level rise design? Forget that was a sidebar. Just to, I'm back to. Sorry, I interjected that. 40 years is reasonable time frame for an on-site wastewater treatment system. If there's going to be sewers in the future, then designing a shoreline protection device for a 40-year time frame is reasonable. That
What is the reality of the design of that shoreline protective device? I mean,
Right,
is it,
that's the next question.
Okay.
After we got the time frame, then the reality is that you have to do a coastal engineering study, and the coastal engineering study, based on current practice, would include some sea level rise component.
but how many of the systems need to be upgraded? How many are in failure?
According to the email from the Regional Water Quality Control Board, any conventional system is in failure, and that's 90% of them.
Well,
Oh. Okay.
right, the
all right.
inspectors have to, the septic inspectors, the registered Malibu septic inspectors need to go out there and do their evaluation. If they find that it's in failure, then they have to upgrade it. But if it's not found to be in failure, they can still continue to use it?
In that conversation, the discretion by the water board has shifted. In April, they stated all of the septic systems were in failure, the ones were on the beach. Since then, the state of California and HCD has had different conversations with them. A meeting is being set up in the next week or so with the Attorney General from the state of California, the city of Malibu, our city attorney, to discuss that what you stated. The interpretation by the state of California is that the city should be able to reuse the on-site wastewater treatment system conventionals that were there, and that's where it's going. We still need to have the meeting with the water board, but that's where the conversation is now shifting towards.
That's very encouraging. I mean, the problem is, I mean, I've been a litigator for close to 40 years. We can be absolutely right, but if another party with equal jurisdiction takes a different position, you need to get an arbiter, usually a court, but in this case, perhaps the governor, to break the conflict. So we may be 100% right in our interpretation, and there may be lots of OWTSs that have not failed in our view. But if the water board says they have, until we have a decision by a judge, the governor, what have you, we're stuck with a deadlock.
Well, and just to put my word in there, I understand that, but I mean that's why we have a registration system. We have our local area management plan that has the guidelines for who's considered an expert and an inspector on these, and I think that their technical expertise needs to be part of that conversation also. I mean, not that it just. We need to allow those systems that are functioning and are safe to continue to operate until such time that their lifespan is over.
And you are correct. I think that's where the conversation is going. We just need to get ratification from the water board, which will happen very soon.
So then we're still talking about whether it's a conventional existing system or a future system. If they have existing shoreline protection that is capable of protecting that system, right, continuing to protect that system for the anticipated lifetime, nobody's going to make them take that out or modify that if it works. But in the case where there is a new shoreline protection device needed for either an existing system or a new system, we're talking about agreeing that 40 years is a reasonable time span if sewers are coming in. I mean, that's the lifetime of a new system or the lifetime of anticipated sewers. Would that be a reasonable, is that a reasonable aim or goal or pin to put in the ground?
Could I ask a question of the two city council members here? What is required for the city to bring in new sewer systems? Does the entire city have to vote on this? Okay, I'm unfamiliar with the process.
So Rob DeBow did a presentation at a council meeting. I don't have the Jorge or Tatiana. Okay. So I would go back, I'd look at that presentation. You can also talk to Tatiana and Jorge, and maybe they can give some more timelines and things like that. But it's proceeding. They're projecting 5.5 years to operations. Everybody could be hooked up and operating in that.
That's in the entire city or just the burn area?
Just the burn area, like Carbon Beach Terrace, east.
Yeah, if I can add, please. Yes, the August 11 City Council meeting has a presentation with a lot of details on the sewer and the timeline and what needs to happen before that decision is made. As Mayor Regan said, we are having number of meetings, including ad hoc meetings, to discuss the sewer system, and that we're talking about the beachside homes in the burn area being connected to Hyperion.
Yeah, but it doesn't necessarily require a citywide vote. The city council could decide to subject it to a citywide vote, which is a political issue that's going to have to be resolved. It could require a vote of the homes impacted if there's a what do you call it? Assessment district created. If there's no assessment district created, that is another can of worms that has to be decided. So there's a lot of moving pieces. Bottom line is there's no answer to what will be required. Legally, the city council could simply authorize it, but I doubt that three votes are going to just authorize it without some kind of referendum by a minimum of the district, if not the entire city.
Just because we're here today in the city of Malibu Incorporated because of sewers, and that's why I brought that up. So
I may be in the minority, but I have expressed the view that I want to understand what the whole city wants. It's not just a question of what the homes that are impacted directly by it want.
So I guess then back to the question that I had directed then. So 40 years may be a recommendation for if you need a new seawall to protect an existing or a new sewer system or a new existing or new system on the beach. 40 years may be the recommendation for the time frame, the design time frame that you're looking at, right?
I think 40 years is obviously it's acceptable. I think if we use the current numbers, we'll be on the high side once we get to that 40 years. Again, I want to, the sound of repeating myself, these seawalls really don't fail by being overtopped.
Understood, but we're going to leave that part. That part is, my recommendation is going to be that be left to the coastal engineers as it's specified currently in the code, where it says a shoreline protection device will be designed by a coastal engineer, and as engineers, we have to meet the standard of practice, right? And the standard practice is not a static thing. It's something that progresses, right? And so I don't think we should specify the depth. I think maybe make sure that the methodologies that are used to determine that depth are consistent, I think is more important. So then the next question that we were discussing is then what is the sea level rise, or what are the wave forces that need to be considered on the foundations? And we didn't come to a consensus on that.
Before we move further, it's 40 years. We use a lower number. Will it make a difference if we use a lesser number of years?
Whatever anybody thinks is maybe perhaps a reasonable time frame. 40 years is typically how long a system will last. System.
I did a real quick calc on sea level rise, and if we project out 40 years, and we use the high category, we'd only be at 2.4 feet. So, if you move over at 2.4 feet, if you move over to the intermediate high category, you would be at 65, 1.5, 3.6, 1.8, right, in the intermediate high category. So it's reasonable for 40 years.
Okay, and then just to kind of wrap it up, the other big question was, and brought up by your excellent slides and everything, is what is reasonable sea level rise then to use on for design of foundations, right? That was a question that Garrett, do you have comment on that, Garrett? Or time frame or whatever, and how should that be determined?
We should be designing structures for a minimum of 100-year lifespan. That's not the protection devices, that's the house themselves. The houses should last at least 100 years.
Requirement, or is that just something that you think makes sense?
I think you're going to find that the structure and the foundation of the structure is going to be governed by the seismic requirements and not by the wave forces. And if we use 100 years for the design of the wave forces against the structure, it's fine because it's still going to be it's going to be minor by comparison to what the seismic requirements are going to be.
Lauren, may I add a point here? Sorry, to the previous discussion that you had with your engineer. Excuse me, sir. To your previous point that he mentioned that we can also make the statistical analysis of 1% to the beach profile. I just want to, sorry, with all humbleness, I've done from a master's hydrodynamic quality modeling, hydrostructures modeling, and also contaminant and sediment transport modeling from postdoctorals. To calibrate and validate a contaminant and sediment transport also for a beach is going to be a huge success. And if you please find a good validated model for the beach of Malibu, I would be very happy to study that. Just to find 20 readings and just to make a local statistical analysis, we have to be very careful. But I take your advice if in long terms the city of Malibu wants to have develop some kind of a beach protection plan, because based on your experience, majority of these seawalls has been damaged from the beneath, not the on top. That would be good engineering practice. But to say that from that perspective, maybe 1% is to look into the 1% instead of the sea level rise, to look at it from the beach profile, I think that we have to be careful. Thank you.
Wrap it up. So conclusion, structure needs to be designed to the FEMA base floor elevation +1. The forces on the foundation will need to follow code. Seismic will govern. That will not alter possibly the height of the foundation. Then separately, we talk about shore protection devices, which is your seawalls. They will need to be in compliance or follow the 40-year, anticipating that we're going to have a sewer system, and our coastal guidelines and our coastal reviews will follow your recommendations. So when you're justifying the 40 years, as you are writing your coastal reports, do you need any clarification on that, or you are clear on what you need to have for?
I'm clear. Yeah.
Yes, sir. That is correct.
But just to be crystal clear, maybe it's obvious, but that conclusion is where we are as far as what's coming out of this meeting as a recommendation. That's not the rule that you can bank on until the city council votes on it.
That's the lowest. That is the lowest. That's the way I'm understanding the way this conclusion is.
But your height's going to be measured.
Your height can be measured from that because you're not going to, well, your height is
your height is going to be measured from
historically it's been measured from the finished floor elevation.
That's CDP. That's an LCP interpretation.
Okay.
This is coming out of the fire rebuilds things.
As a coastal engineer, I don't get involved in the height of the structure.
Right.
That's the architect. So.
Thank you.
But it's going to make a difference when you're structurally design it, because you're not going to have.
Yes, Madam Mayor.
I had this conversation with Dean during the break. I just want to point it out. I mean, I've been pressing a number of the questions I've been asking for specific rules that set maximums and minimums, and depending on whether you're talking about height or depth. I want to avoid, as best we can, situation where a reasonable expert comes to the city with their plan and the city has a different view discretionarily of what it ought to be. As a lawyer, I hate standards, I hate guidelines, I like rules. I like a 50-mile-an-hour speed limit, not drive reasonably safe for the conditions, because I can't measure what's reasonably safe for the conditions. 10 people can have 10 different answers, but if 50 is the answer, 50 is the answer. So that's why I've been trying to press for some kind of answer, either a specific methodology that's scientific or a specific depth, which is going to be, no one's going to argue to you, you have to go lower than that. You can go lower if you want, and you can't go higher as the depth. But that, I sense we're not going there. But beware of retaining flexibility on your part, because that means there's also flexibility on the part of the deciding party, which might have different discretion than you do.
Yeah, it would be great to have, like, okay, go down to elevation zero. Actually, we could say take the seawalls down to elevation 0, because that's right around mean low water, and that would be the absolute lowest.
And some people are going to end up with a greater expense if you do that, and
Right.
other people are going to end up with a lesser expense. But everyone knows how to plan and what they're shooting for. I would rather see that.
But it does depend on there's a variation between beaches and even sections of beaches where this all occurs. So,
Sorry, can a methodology be proposed to be followed based on the LA County standards and the standard of care, et cetera, like just kind of a codified? Is that something that?
well, the LA County standards were the 1%. Okay, if you look at the literature that's been done in Malibu in the 1970s and 80s, it's that 1% of lowest beach profiles. That was the standard of practice, and to my understanding, it's still the standard of practice today.
Like that.
And I'm sure the engineers here, the technical people here, will be helpful in that endeavor. So.
I respect your input, Rich. I just want to make sure that the council is hearing from everybody. So if you need to speak up or make any recommendations, or you just agree with what Rich is saying, council need to hear from you.
I have one follow-up comment for the city council here. Oh, I'm sorry. Go ahead.
The one follow-up comment I have from this is you're basically starting a milestone date where you're at. I think you want to start looking then forward in 10 years. You guys can pick the date, but come back and look at where you are 10 years from now from what you thought you were going to be at, and see whether or not you have to accelerate things or whether you're going to slow them down. But every 10 years or so, you need to come back and reevaluate this and see whether or not you need to be slowing down or actually have to accelerate the process.
I think what's unique about this is just these are for the fire rebuild.
This is for the fire rebuild.
For adopting.
No, but it's going to lead into that eventually.
Maybe not. I mean, that's actually going up to the Coastal Commission and the local coastal program and the state standards
for this part. But I think as you start to evolve the principles of how you're going to do the coastal engineering, you've got a milestone date here, or you've got certain numbers. I think you want to take a look at that every so often to see whether or not are we ahead of schedule, are we behind schedule, where has this gone? Just so you have a milestone, because you don't want to be 10 years from now going, how the hell did these people figure this out 10 years ago? What were their milestones? What were their bases for this? Because this is something that's going to be in flux. It's just nature.
So I want to go back to that depth for a minute, and maybe this is just ridiculous. I don't know. Why couldn't we adopt a rule that said it has to be at least as deep as it actually was on the day of the fire. And then it's up to your engineer to decide whether you need to go deeper for safety or not. Why wouldn't we? I mean, could we do that as a statutory matter, or would that pose a problem with the building?
A lot of the seawalls, we did not know the depth of the seawalls. They're so old that we don't know the depths.
Aren't they there right now?
They're not code. Most of them are not code conforming.
Yeah.
But they are in fact there. You can dig down and find the depth. It's not burned. It's not gone. And it was perfectly fine. At least, nobody was tearing them up and replacing them before the fire. They were living in their homes before the fire with whatever depth they had, and they weren't failing for the most part. So why couldn't we just impose as a law that you must build it to the same depth or lower if you choose that it actually is right at this moment as it sits there physically?
Can I make a comment real quick about that? So you're assuming that they weren't failing. I can't tell you how many repairs or deepening of walls that I've done in the last 30 years. So I can't even count them on my hands. It's
Yep. I would also just caution setting policy that sets the standard of care so low and has it be city policy to say, you're essentially making a case that it's a resident's choice if they decide to build above BFE 1 because their OWTS system seawall had to be higher. So now it instead of it becoming a policy that the city's recommending a standard of methodology, now we're saying, well, you didn't actually have to build to 20 feet. You only chose to build to 20 feet because your coastal engineer said that you had to, and your house has to be above that. But I'm going off BFE 1, which was 19 feet, and now I'm going to restrict your height by a foot, and that's your choice for hiring. You're essentially setting a lower standard of care and directing owners to go to the least conservative consultant that they can find so that they can build down to 19. But that's bad policy for to change your standard of care.
I totally get that. And like I said before, when we're talking about a voluntary rebuild or a new build, I want to be resilient and conservative. But when it comes to a house that was sitting there, 300 homes that were sitting there that were all destroyed, nobody wanted that to happen. And they, 5 out of 300 is 1.5%. I mean, why should the 1.5% dictate the 98.5%? That doesn't make sense to me. I would just say these are extraordinary circumstances. The governor has been waiving things left and right that make sense to have in the grand scheme of things generally, but doesn't make sense to have if we want to get these homes rebuilt. And I'm in favor of finding every way we can to relax the rules if we can do so legally consistent with the building code that we're stuck with.
So maybe a better solution will be providing a methodology in which this needs to be done instead of just setting a standard. So I'm asking all of you coastal engineers, what is the methodology standard that the city should be followed? And so
the methodology already exists. It's coming up with a design beach profile and going a minimum 2 feet below it for the bottom of the seawalls and the return walls. That's why we can step up the return walls following that design beach
knowing
profile.
that we already have a standard that we follow, I want to hear from the other coastal engineers because I am the one getting the emails on when you guys do not agree with our coastal engineers. I am the one setting up all the meetings and I hear from all of you, but in here, no one is talking. So I just really need to know, it's everybody okay with the standards that we have and you guys are okay with what is required. So there is no ambiguity. Because my homeowners are telling me, we are running out of time. We need the city to set up guidelines. And so far, I hear all of you, but not all of you are speaking. And I just want to make sure that I'm not going to get those calls, that I'm not going to get those emails, because you were given a time to speak. And I'm just going to say, well, you know what? Your technical team where it's on board with the standards that the city has. I just really need to hear from you.
Standard is a decent standard, and I think consistency is important, particularly when you have different people building at different times with different design teams on the same beach or in adjacent beaches. Consistency, I think, is very important, and the existing county standard is a reasonable standard.
I have a question for Reg or Joe or other coastal engineers. Does that county standard provide a method only for determining the seawall depth or scour depth, or does it also speak to the sea level rise question?
The depth of the seawall is not dependent on sea level rise. The depth of the seawall is dependent on the location of the most landward mean high tide line. And that's why you have to keep on getting new surveys.
Yeah, thank you. And I only asked the question because from what I was presenting, but also hearing in this discussion, is that there are two very important open questions. And one is the methodology of determining the seawall depth and scour depth, but also the sea level rise number.
The sea level rise number is going to affect the height of a wall or height of something, but not necessarily the depth. You know, there's something that I wanted to ask because this is what I came here for today, and I don't want to prolong the agony, but let's talk about materials of construction of the seawall. I've been hearing no more wood seawall, and I want to know why. I don't want to hear because the code says you can't have a wooden retaining wall. That's Boulder Dash. That's been there forever.
And I don't know why you waited so long. This was answering during our beachfront properties presentations. Wood is an acceptable material for seawalls. So we're seeing right now coming in on our reviews, wood, and other people have decided to go with concrete. So the material is not it's not an issue for discussion on this. The city will be looking at any materials that you guys are proposing to do.
So we can use wood if that's what the client prefers, or if that's what we can save the money on.
Like that from you is because this is something that we pulled from the LA County Code. These seawalls at times are retaining walls when the beach scours down, and so I guess we need a specific code interpretation about section 1808.2 from LA County Code, which talks about no more timber seawalls, or no, sorry, no more timber
zones, in certain
walls.
seismic zones.
Right.
Retaining walls in certain
right.
seismic
retaining
zones.
walls, right.
Yeah, we can look into that.
Of course, yes. We've gotten around that in the past with previous building officials for the city of Malibu. Vic Peterson and Craig George, they were allowing the wooden seawalls.
Yeah.
So,
what Lauren, what you just said, as I heard it, was these seawalls act as retaining walls under certain circumstances, but they're not designed, as I hear it, as retaining walls. They just have
they are designed as retaining walls.
So they're called a retaining wall, or they're called a seawall for purposes of protecting the OWTS. Which are they? Or are they? But are they legally both?
They're not retaining all the time. That's the issue. Okay.
But are they a seawall that happens to act as a retaining wall under certain circumstances, or are they retaining walls that also act as seawalls?
It's a story of roses and different names and different smells.
And that's what the law and that matters to me as a lawyer.
You're always going to have the sand behind the seawall. You're not going to have the seawall. That's number one. Number two, what's What's the difference?
The
You've
difference is
got
whether you're going to be able to use wood or
all-
not.
All the way along your highways.
The difference is you said you would like to be able to use wood, and I'm hearing that if it's a retaining wall, you can't. So I'm trying to understand if it is or is not technically a retaining wall, because if it's not technically a retaining wall, you can use the wood you want to use. If it's a retaining wall, you can't use the wood you want to use.
That's the way the code, the LA County code is situated right now.
Right, but we have the ability to interpret it, and that's what I'm trying to get at now. So is it, in fact, from day one, being built as a retaining wall, which also is a seawall? Or is it simply a seawall, which happens to buttress the property when necessary, even though that's not what it's designed for?
So it's almost always retaining. Twice a year, it retains even more. So it's from day one, they're always retaining some sand.
So if you didn't need the OWTS, you would still have it because you need the retaining wall?
No, it's retaining because of the OWTS.
Okay, so doesn't that mean it's just a seawall and it happens to have the benefit of serving as some extra retention when necessary? If you don't need to have it otherwise?
Is you don't design a wall for the least of the loads, right? You design it for the maximum load that it's going to feel. And so that means it's retaining.
So at the end of the day, this needs to comply with that building code. And so I think that discussion needs to, we will get it done. I think we're going too much into in things that we don't need to discuss. It's 12:31. Is anything else that we need to discuss or our city council needs from us?
I apologize. Based on the 100-year design expectancy, so therefore I think the 4.5 feet of sea level rise is a good engineering practice. Thank you.
I have what I need for purposes of the city council meeting as of now, but you never know what kinds of questions and facts are going to come up when we have the meeting.
So that concludes our presentation and our technical discussion for our coastal group. We have 30 minutes for the geo. Lauren, do you think we can do it in 30 minutes or at least start that conversation?
We can probably throw out the presentation except for the one slide that we have of questions that we are getting, and we can just put them up there for people to then comment on.
And these are questions that we're getting from our families. I asked all of the geotechnical engineers and geologists in the room to join the table now. Thank you.
Yeah, I mean, the limited report. Well, it's been coming to her. I get the hard.
That's it. Mark, do you want to take the microphone and introduce yourself? We will start our geotechnical session. I want to reintroduce to everybody our mayor, Marianne Riggins, and our mayor pro tem, Bruce Silverstein. We are now going around the room introducing the new members that are sitting at the table, and I will start with Mark.
Hi, Yolanda. Mark Barrett, certified engineering geologist with GeoConcepts.
Brett Warner, CEG with Advanced Geotechnical Services.
Richard Gladson, CEG with with Geosystems.
Andrew Sheldon, registered civil engineer with Sheldon Engineering. Not a geotech, but I do civil design and work with these guys a lot.
Hi, Josh Pfeffer, CEG with Pfeffer Geological Consulting.
Larbi Azaz, Community Development Planning Division.
I'm Mike Phipps, CEG, and I've been a geotechnical reviewer in Malibu for most of the cityhood.
And there's 31 members, geotechnical and geologists joining us through Zoom. So we're not going to go through each one of their names, but we're just saying hi. Thank you for joining us.
Thank you for joining us.
And with that, we'll start with, we had a presentation, but we're just going to keep it straight to the questions that we're getting over and over again, and also trying to answer any other questions that you have for the team and for the city, and also going over any questions that you may have about our geotechnical guidelines. So with that, limited report. Do you want to respond that?
I would say yes, exactly what's needed. So for instance, the city of Los Angeles for fire rebuilds has designated large swaths of areas that don't even require a report, and other areas where we're providing geotechnical reports based on historical data, assuming that there is sufficient data. One can discuss what sufficient means, but you know, if there's been borings done on the site, if there's been test pits and laboratory testing, even if there's not been done on the site, if it's a couple of doors away, and we think that there's plenty of information, the city of Los Angeles is allowing us to write a report based on that with no subsurface work, no laboratory testing, and they are approving these reports.
So I would say, based upon our discussion with your engineer, Alexander Green, we had a discussion about that, and that is, if there is sufficient information, we are not requiring, we're leaving it to you. If there's existing information and it's representative of the site, you can do that, and no additional exploration is required. So that, Farah, maybe if you can go a little bit further, this is not working. The other way, sorry. There we go. Yeah. So a limited report could mean no exploration, or if you feel like you need to do maybe just one test pit in a particular area where you're not sure, it could mean just one additional test pit and using existing information. So we are not requiring. If there is data and you can make the argument and characterize the site correctly, or not correctly, but adequately for design.
And I would add that the offsite data you use, I mean, it has to pass the LAF test. If you use something that's half a mile away and in a completely different terrain, which people will try to do, we're going to call that one out and say you probably need some site-specific data.
in this explanation here, who is the geotechnical consultant? The city's person or the applicant's person? Okay, so if they come and say that we're satisfied in our professional opinion that we have enough information, that's the end of the question?
They can't just say, make a statement. What they have to do is they have to demonstrate that it's representative. This is not the entire definition. This is a further explanation, but okay, this is not what's in our geotechnical guidelines. This was an additional explanation. When we say believe, if it can be demonstrated.
So, okay, so they must demonstrate it to your satisfaction. So ultimately, you're the geotechnical consultant that has to.
No, not demonstrate to our satisfaction. They have to demonstrate that to the standard of care and standard of practice.
As refereed by you at the end of the day, correct?
As refereed by the code and the adopted
code doesn't
guidelines.
So I think you're bringing up a point, which is a very important one, which is the city of Malibu process is one that is slower from a geotechnical standpoint than every other municipality that we work in. There's more review sheets. There's more. It's a longer time frame. The back and forth goes on for more iterations than it does in other municipalities. And one of the reasons is, in part, because when we provide a report and an opinion that we are the geotechnical engineer and geologist of record, that may get questioned and asked for additional data that as though we've got a couple of consultants on the project. So I guess that's a question of the streamlining of these things, and it's a good point that Bruce brings up, is at what point in time are we allowed to say that's to our satisfaction, even if it's not to yours? I mean, it's a statement in terms of, you know, we look at these fire rebuilds that we're doing, and we have over 100 projects in the local area, and the question is, we would like to get those through the system as quick as possible for the benefit of the homeowners. And the question is that the city of Malibu's mantra as well, or is it the city of Malibu's mantra that no, we would like to get it done as quickly as possible, but we're really going to go through the normal process, and these fire rebuilds are not being given an additional sort of concession in terms of timing and speed?
I think that a couple things there. Number one, our goal was to expedite the whole process with these geotechnical guidelines for fire rebuilds, and identify places where we can speed the process up. And one of those was a statement that you can use existing information. I think from a reviewer perspective as well as a practitioner perspective, people, you know, engineers and geologists operate on a comfort level basis. You know, it's like if you have data that's on the site next door that characterizes the site, and you're comfortable that your conditions on the site are going to be similar to that, that's totally acceptable. And I think we're going to come to the same conclusion. We're not trying to create a situation where you must go out and dig every site and get new data. I think that's excessive for fire rebuilds. So we are trying to give this more attention. We are trying to meet a very short turnaround time on the reports that we're getting, and we're trying to expedite this process.
And so I will say, with respect, because I had this discussion with Alex, we met over one of the sites. If it's a flat lot, I mean, that's why we broke things up into flat lots, you know, lots more increasingly. If it's a relatively simple lot, we are far more likely just go, right, if it's your opinion that this is representative and you can use code confirming values, great. I think it's a matter of level of hazard and risk, right? And we tried to break out categories for these reports, you know, basically from a lower risk to a higher risk standpoint.
One other distinction is, and we had this experience in all the fires that I've worked on, is the difference, you know, a change comes when the footprint changes or you start building closer to a slope, or, you know, whether it's a ascending or descending slope, and you don't necessarily know the conditions there. And you might need to analyze the slope at that point if you're going to be loading it or building right on top of it. So there are it's very circumstantial. There are situations that arise. I mean, these like for likes are hopefully should be in the same footprint, but that can shift almost by 50%. And there are going to be circumstances where, and you know, we want you guys to know this as the practitioners, is like, oh, I'm going to need to demonstrate X or Y because I'm closer to this slope, whether it's ascending or descending, or if I need to justify a alternate setback from what the code would specify. So it's very circumstantial, and you know, if your client wants to build in a certain direction that the house wasn't there before, and there's no data, it's going to come down to your judgment. Like, I think I know what the condition is under here.
And I think, I'm sorry, I know you needed to speak, but I just want to make sure, because you did a statement. Your mention is the city still willing to help out the residents and the families rebuild, and that is our number one priority. We have had multiple meetings, and we're still, every time we hear from the families that we need to dive deeper and see how you can help us out, this is what we're doing. And that's what we're having this discussion. I think for me it's clear what is on the code, it is on the code. So, and you as design professionals, and I'm talking to all of you, we cannot diminish what it is on the code. So when we're talking about geotechnical, the city does follow the county, and we do have sections and findings and that require those reports. And I'm looking at 111, 110.2.3.2. So the guidance for those requirements are already there. What we wanted to get out of this meeting, and what I want to get also for me out of this meeting, is that I'm hearing a lot of the families, my geotechnical engineer does not know what a limited report is. My geotechnical engineers, it's charging me for a full report, and is a full report the same as a limited report? So for us, it's just get clarification so our family knows exactly what they're gonna need. And when we're talking about limited report, I really want us to have a conversation and like, what is it missing from this definition that is not allowing to do your job? And to me, that is a question here. It's not, are you going to do this or are you going to do that? It's what is it missing from this definition that we need to give you or provide you clarity so you can help our families rebuild.
First of all, I want to apologize in advance that I have a hard stop at 1 o'clock. And I know I prolonged a lot of this. But the question I heard being asked was, does everyone understand what a limited report is? And then the one person that commented talked about what is the standard for when a limited report is acceptable. So there's two questions. What exactly is this report? What are its contents? What must it have? And when is it acceptable and when is it not acceptable? I'm not sure which of those two questions was really the one that was being asked, if not both of them. So I'd like to understand that. But at the end of the day, I got to say, when I read these things, it's very clear when it can't be used, but it's not at all clear when it can be used. At the end of the day, it all depends on the discretion, I think, of the staff member who's looking at it. And that's something that troubles me all the time. And I dig, whenever people come to me with that complaint, I dig down and try to get to a place of what are the rules that can be used that no one can debate what the answer is. And I'm never able to get there because there's always some answer that makes it discretionary. And I think that's the problem that you're identifying, and I don't have a solution for that other than to adopt rules. But every time I try to adopt a rule, I'm told why it won't work.
Remind that this is not for adopting rules. The rules are already set.
Well, but that's what so how does the matrix tie into this? Because when you go to the matrix, it describes a variety of different property types. And then depending on certain either known or unknown factors of that property, it gives guidelines as to what type of report, whether it's a limited report or a full report. Is that help clarify some of this, or is even this matrix still causing confusion?
So, I mean, the proof of the pudding is always in the eating, right? So, yes. And the question then is, when that report goes into the city, is it going to say, like, okay, I think it was just brought up that the discretionary portion of these is large and governs it ultimately. So we're writing phased proposals now. We say, look, we're going to provide you a report if, again, there's sufficient information historically. We'll provide you this report without going and doing a subsurface investigation. And then we don't have the experience now because it's too fresh from the Palisades fire, but that would never have been a consideration before. And invariably, I would expect the question to come back and say, well, you guys didn't do any work on your site. Now you got to do it. Or you got to, there's other things, right? There's the city of Malibu, like, adopted having to do fault reports based on Tryman's old report, which the state didn't. You know, they adopted certain fault areas that made it into the AP zone maps. But we in Malibu have to do fault reports all over the place within 500 feet of a fault that was shown on the Tryman map from 1993, where he said this is not an active fault. But the city of Malibu says, yeah, you got to do a fault investigation anyway. So there's those things that need to be done still when they, for instance, from the Woolsey fire, it says, and we comment this back in a lot of our responses to review sheets, where it says, specifically, you do not have to do a quantitative analysis of X, Y, or Z. And we then give a qualitative analysis of that. And then we get a question back that says, yeah, but give us your slope stability analysis. And you're like, well, that's a quantitative discussion. It's not a qualitative question. And so it's, again, that's the amorphous area of trying to get through some of these things.
Let's hear from other engineers to see if they feel the same, or I just want to hear from other people, knowing that.
Yolanda, we do have a question on Zoom regarding this topic.
Okay.
If we'd like to open it up to Alexander Green from Geotechnical. Alexander, I'm going to unmute you.
Hey there, this is Alexander Green. I'm actually with Pfeffer Geological Consulting. So a couple of things that I wanted to bring up. One, which is that I think every consultant here recognizes that the city of Malibu probably issues more review sheets than any other municipality for projects. So my question to the reviewers is, are you guys going to be doing everything within your power to reduce the redundancy in questions that are being asked, and therefore reduce the number of review sheets? So I'll let you guys answer that, and then I will ask another question in a moment.
Alex, are you there?
And I will repeat the question.
Great.
And Alex, you can stop me if I'm missing anything. The city of Malibu reviewers usually gave us a lot of corrections when a project comes in. Through this rebuild, is that consultant geotechnical engineers are going to do their best to not give us so many corrections.
Yes. The answer is yes. We are going to do our best to not do redundant questions and to have plan check comments, separate them out from those that the geotechs really need to address versus stuff that just needs to be corrected on the plans. related to foundations. And so, yes, the answer is yes.
So before the next questions, this came up in the coastal portion of this. And I just want to say, as a council member, when I'm looking at this and I'm trying to help kind of guide this, the fire rebuilds are different. We're trying to get back that home that existed there before. So trying to make sure that the guidelines and the rules keep that in mind, that that house existed, it was stable, maybe it wasn't stable. So we need you guys to be putting forth things that are going to show how to rebuild that home back. It's going to take some trust also. I think Yolanda talked to the coastal engineers about this. We need you to talk. We need you to be honest. We need you to tell us what you're experiencing so we can get some good dialogue and we can cut through and make sure that we're actually getting to what the minimum standards are so people can get rebuilt. So, Yolanda, maybe you can.
No, and this is and we will go back to Alex in a second. That's what we're having this meeting. We really wanted to hear from all of you. You are the primary contact with our families. And so we need to give you the tools for you to be successful. And you gave us a report so we can continue doing our reviews and get our families back home. The city's main priority is our families. How can we help them? But right now I'm hearing my geotechnical engineer is taking a long time. My geotechnical engineer needs more explanation. We don't know what a limited report is. They're charging us more than what we don't get involved on how much you're charging. But if you have specific questions, please utilize this time for us to address this because we're running out of time with our families. And there's a lot of questions coming our way. So we want to facilitate those for you.
I guess I have a specific question, and I'm not quite sure how to couch it, but I'm working on a project of a rebuild in Big Rock. It's clearly on a landslide. There's clearly going to have to sign a waiver. It's atop of a coastal bluff, and I've heard conflicting things about whether I need to do a stability analysis at all. I've been told, oh no, we know it's a slide, so no stability analysis. And then I've been told, well, but maybe you should analyze some of the smaller slopes or some of the local slopes around. So what is the policy on stability analysis in Big Rock?
If you're on a bluff and there's an indication that there's potential instability below the local, I mean, everybody knows from a large perspective, you're on a slide. Nobody's talking about slope stability from the large slide. But if there is a local slope that may have some instability or some exhibited, we want you to discuss that at the very least and whether that's likely to impact the slope, right? Now, if it's superficial instability, no, right? Because the superficial instability is unlikely unless the house is hanging out over it, right? But if it's a slope and there's no evidence of movement and there's no evidence of cracking, then and your foundations are set back far enough, I don't think it's a problem. It's the kind of thing where we're looking for you to tell us whether you think there's an issue or not.
Oh, okay, so you're talking about a cracking or instability.
Aerial photo evidence.
Yeah.
Aerial photo evidence of a potential problem.
Yeah. So because I look at my bluff, and it's descending from the building site, and the building site or the building is pretty far set back. But if you look at the bluff, it's the Big Rock Mesa landslide. There's all kinds of potential for toppling and boulders to roll off of that bluff. But you don't want me to. I don't have to address that is what you're saying.
What do you mean you don't have to address that? You need to address the condition of the slope below the property and talk about it relatively with respect to does it pose a risk to the site or not? If there's some sign of instability, what is the condition of the slope? If it's steep and the code requires a qualitative discussion.
Okay.
We expect that to be a robust qualitative discussion.
But you're not looking for a quantitative stability analysis.
Not necessarily, no. Not unless there's signs of instability at the top of the slope where there's cracking.
And to be clear about all this, we're discussing like-for-like type rebuilds at this point. It's not necessarily what would be classified as new construction. So
Right, right.
Same footprint plus 10%.
Right, you're not moving any closer to the slope. You're not putting any structures that are out on the slope. You're not changing. It's really all about the risk level. Are you changing the risk level, the risk exposure, right, to that particular hazard? That's what we're curious about. Does that help clarify?
Yeah, just because you were talking about, moving closer to the slope and foundation elements and things of that nature. So I just wanted to make sure that, we're not, and I think it was all understood. I'm just wanting to hear it, that we're talking like for like type reconstruction. So,
right.
There's
You
a
still
house
have
right
to meet
here.
foundation
You're putting
setbacks.
a house right there. Yeah.
Right. You still have to meet foundation setback requirements, though.
Mm-hmm.
Right. Those, because that's code. And if you want reduced setbacks, then you have to do the local slope stability analysis, because that's required under the LA County standards, right, for reduced setback, for requests for reduced setbacks.
In the bedrock, in the Big Rock Mesa area, then we don't, of course, the assumptions for the slide plane shear strengths are way different than the assumptions that we would use for the bedrock or landslide affected bedrock. That's
correct. You wouldn't be using the slide plane or the weak material down there. It's the kind of thing where I'd expect you go to the seismic hazard report, right, and look at the representative rock types, right? And we have that discussion with Alex.
Applicable, and in that situation, CDMG values would be acceptable?
Right, but you'd need to connect the dots, right? You can't just go, oh, this map says it is this, therefore I'm going to use this. I would expect you to go out and look at the site and confirm that that's the type of bedrock that's there, right?
Understood.
And that you would look at the structure, right, and make sure that the structure matches.
Understood.
I mean, basically, a basic justification for, and when I say justification, a technical basis for why you assumed that, a technical explanation for why you think it's applicable, or why it is applicable.
Hey, Lauren, I thought you were requiring local slope stability, especially up in Bedrock.
I don't think everywhere. Not
well,
everywhere.
Yeah, I think that was the interpretation that we had as well, that we were required to do local slope stability, and that brought up the question of what shear strengths we were going to use for that.
Yeah.
Now that we don't have to, that it can be a qualitative.
Yeah, I think it's only in the circumstance when you're building closer to the slope than the pre-existing house, and the slope hasn't shown any signs of issue. So if you're encroaching on that slope, then we would want that analysis done.
And what about the factor of safety you're looking for on that?
What we're looking for is not any particular factor of safety. What we're looking for is a characterization of the hazard. If you're not moving any closer to the slope, or because you're signing an assumption of risk and release, right? The assumption of risk and release points to the report that you're writing to describe the risk, right? Low risk, moderate, high risk, just so that people know what they're assuming, right, in terms of the assumption of risk and release. That's really what it is. And I think from the Woolsey fire perspective, this was the big issue that we had with respect to faults and other things, is we were seeing a description of the hazard, but we were not seeing a description of what risk that posed to the structure. I don't care what risk it poses overall to the, you know, to the slope that's, you know, too far away from the structure to pose a problem, but really with respect to the structure that's being rebuilt. So here's what I would say is, if you have any questions on a bluff property in Big Rock, because there's not that many, just come talk to us or set up a meeting and discuss it.
So just going back to the question of local slope stability for Big Rock, just to the group is clear, it's not required everywhere on Big Rock. Is that correct? Is anywhere on our guidelines that is giving the design professionals that we need to adjust or change for clarity? Would that help you?
My suggestion is going to be that we revise to address, you know, I'm looking at this and it needs improvement and it needs clarification. And specific statements like that, I agree, probably need to be put in there specifically.
Yeah, and what I would like to see just for the homeowners is that there is some glossary or some information provided about the technical language, so that when our homeowners come to the city, say they come without you, they come to the city, they're being told or they're being suggested or they have to ask you something, that there are specific terms that are universally understood. So if they were asking for a limited report, what does that mean? So that we don't have this lost in translation about what staff is telling them and then they're telling you. I just want to make sure that everything's clear, that our homeowners understand what is being asked of them, that you understand when they say something, and that you can maybe clarify that when you hear certain terms, you can explain to your homeowners actually, well, no, this is what the city means about that. I just want everybody to be on the same page so that we don't have confusion and we're not playing a giant game of telephone and people are just being confused by this process. They've already got 14,000 decisions that they're having to make, and this is something that is so specialized that it's causing a lot of confusion and I think a lot of angst, and I don't want people to get dissuaded by the process because they're overwhelmed with the language. So that's my big ask of everyone.
I think some of the confusion too is that these were written for the consultants, not the homeowners. So we need to make it more homeowner friendly.
Yes, we do. The question is, can you rebuild on existing foundations if elevated and determined to be in good condition, or will fire rebuilds require upgrades to current code?
Yeah, my name's Garrett Mills. I'm a structural engineer, but also the past president of Structural Engineers Association of Southern California. This is really, the city has published guidelines for a process to evaluate existing foundations for reuse. They were updated recently. They came out after the Woolsey fire. The Structural Engineers Association also published some guidelines on practically how to approach that same question. So I very much think that the city's guidelines are adequate for professional engineers to follow and provide a feasibility report with their construction documents or ahead of time for evaluation. I think the process right now is to provide a feasibility report for the city to review and ultimately make a decision on before you go to construction documents.
I would just add the geotechnical part of that is if you've got existing piles, we would like to see as-built information that verifies that the piles are as deep as they were designed to be. Generally, that's in the form of an as-built pile report, but we don't always have those. And if you are going to use a shallow foundation that is on material that is either old fill or soil or something that nobody has any information on, that a geotechnical provide the verification for the presumptive soil bearing value chosen. That there needs to be some justification for that. Somebody needs to observe it, or they need to go look at an old report and say, yeah, right, our judgment is this can handle this load. This fits this category.
Hey, Lauren, so, excuse me. If you have piles, but you don't have an as-built report, then where do you go from there? Garrett?
Yeah. Right, it's not cheap, but you can hire a company to do a test and see how deep they are. Yeah, with the advantage, and I don't say this lightly, but with the advantage that the house is not there anymore, so it is easy test that when it is an existing, foundation on top of an existing supporting an existing structure, right? But I don't know if you are accepting like a.
Oh yeah, we actually did during Woolsey Fire.
Okay.
They went and hired. There's a guy who does geophysical testing, runs out of Torrance. I forget his name. And he came out and tested the foundations, the pile foundations for a deck. It wasn't, the graphs weren't pretty, but it clearly demonstrated that the piles were a certain depth, and we were like, okay.
Yeah, you won't get the inch, but you're looking for 10, 20 feet. Yeah.
Exactly.
But I guess that brings the question, the streamlining of a fire rebuild. If you got a permitted deck that's sitting on piles and nothing's changed, why would the presumption be that you need to verify that those permitted piles are still permitted for their intent? I mean, why not just say, okay, the piles are there, the deck was there, it was permitted, let's go.
Yep.
Structural, I mean, that is, and I'm just saying this, and nothing to do with the city of Malibu, but that gets in the way of a speedy rebuild. And there's a requirement that is often unnecessary if the homeowner is willing to take it. Chris.
Yeah, I don't think I've seen in the city's guidelines to verify the depth by any means other than the as-built drawings that were permitted. But I think it's always, if you have better information, it's always better. And you can, I think my approach as a structural engineer would be to analyze the sensitivity to the depth.
We've also used information from the back of permits where the inspector has signed off on the piles. That's good enough.
I guess, I mean, not to put the city on the spot, but the question was more related to if there was a structure there, can we assume that the foundation system can support the structure, right? And I think, I mean, this is a city's, I think, decision, right? But I don't think that's right. I don't know.
When it comes to the structural and the safety of the property, right? If it's a total loss, the city is still going to ask for an assessment from the structural engineers. So we do have guidelines, like Garrett mentioned, on what it needs to be done. And we're getting a lot of questions just like this. Well, my foundation was there, nothing happened. I'm just gonna why can I just reuse it? The city wants to make sure that we rebuild back safe, and also that the homeowners also, when they're going to have to renew their insurance, that all of those, because all of those documents are being asked by the insurance, that we were ratifying that we did look at it, that it is safe, that it complies with the code, that if it needs to have any upgrades, the upgrades are being done. But yeah, we're getting a lot of those questions. You know, if my foundation is there and nothing happened, the homeowners are thinking that visually they can just say it's good to go, and it's not.
Comply with current code.
Yes. And it doesn't mean that they need to take all of the foundation system out. And so now you are going, and I wanted to keep it back to the geotechnical. Do you want to explain when they're leaving their foundation system, upgrading the foundation system to comply with new code, what that really means?
Yeah, I think the owner should talk to their structural engineer. But I mean, I have my opinion as a structural engineer. You know, just having come from the Structural Engineer Association convention, there were talks about what the effect of fire was on concrete, including a talk I gave. But for the most part, what we're finding is that under the heat signature of wildfires, you'll probably get about a 6-inch penetration of poor performing or loss of strength and loss of Young's modulus, the ductility of the foundation under a 4-hour fire. You would probably lose the first 6 inches. You'd have a pretty dramatic loss of strength. But our approach on some of those is to lose the slab and keep the footings, or take the tops off the stem walls and keep everything below a foot or something like that and rebuild on top of it. You have a lot of considerations for what the strength of the concrete is going to be to receive the new anchor bolts and the new hold downs, and whether or not epoxy is going to work into a fire damaged foundation. So I think your structural engineer on the project would have to address all those.
If I could just jump in. So Garrett, what you're talking about just sounds really easy to me, you know, because you're talking about the concrete that's exposed at the surface, and you just break it off and replace it, as far as I'm concerned. I'm just a geologist. But what I think we're worried about is these deep piles. You know, if you've got a deck or a house that was supported on deep piles, you're asking us to certify something that's 50 feet below grade. And so what we're asking is, what is the guideline? You know, and how do we comply with it logically, I suppose?
For us, it's an observation report or some form of sign-off. And if you don't have that, then I'm kicking it over, because then at that point, I don't know how else to answer that question. I'm looking for something obvious. And if it's obvious, good, give it to me, we're done. If it's not, then it's, I would say it's more than in the realm of the building official and the structural reviewers to provide you an answer to that.
So I guess what I'm hearing...
And if I were you, I would then kick it over to your structural.
Yeah.
Yeah, I think this is where structural and geotech really communicate on the project, because if it's just axial loading, then the pile diameters, if you can justify skin friction values and justify what you see on as-built drawings, the requirements for, there's prescriptive requirements for the amount of rebar in the pile cages and how deep those rebar cages go. If your as-built drawings meet all those qualifications, that's where I would tend to want to reuse those piles. But if geotechnically you have creep on the site that they didn't have when they designed originally, and you can tell from the pile cages that they're not going to be able to meet, then they're probably going to have to put in some at least supplemental piles to deal with those geotechnical forces.
or if it needs to meet slope setback. And this is where, when we talk about this, we want the geotechs to talk to the structurals, right? We want you guys to go like this, not like this. Sometimes you guys end up in silos, and that's not good.
I don't think that answered your question, or did it?
Yeah, I think it did, but I still am hearing my clients in the background saying, "But I had a house there; it was fine. We were told we could rebuild this and have the same house."
They probably
But-
were
and-
told that, but
Yeah.
there are things that have changed in the code over time, as you well know.
Oh, understood.
And so part of it's just going to be a simple answer. Yeah, the pile was put in the ground 50 years ago, 70 years ago. Things have changed. Seismic forces have changed. When we analyze the house, we're going to have to change the pile. We're going to have to put in some, abandon in place what's there and put in new piles or something like that. It really depends on, how much deterioration did we find at the top when you start breaking up. But when we discover there's almost no rebar in it, that's really not going to be something we can use at that point too.
Yeah, those are great. I think 4 and 5 is probably what we should discuss. That's the 800-pound gorilla in the room, I think, for a lot of this stuff. So for this, we would first go to our phased approach, where we're going to try to find soil and geology reports for the residents' original construction, or for, hopefully there's a brand new one 2 doors down that they drilled and they found X, Y, and Z, and we could use that information in lieu of going to drill in a site where we can't drill because it's impossible to drill there.
We have made it clear that if you can do that, okay? You need to then provide the background discussion and justify or explain your technical reasons why you think that this boring over here is representative over here. And in that, we would expect that you're addressing, maybe you go look to see if there's something over here, right? That then you can go, yeah, look, this is the same, this is the same. There's no weird, that there's no drainage in between that would have cut and deepened the bedrock, right? Because we are finding that, I think Hudson found that across a bunch of the Los Flores lots. The stratigraphy changes actually quite a bit laterally across those lots. That actually affects their liquefaction analysis, right? But I think for drilling access on the beach, the big questions we get are the ones more down on the east end, where you can't drill on PCH because of the overhead wires, to which I would say, well, can you not get limited access rigs or low profile rigs there? It's more understandable if you can't get down on the beach, like say in the vicinity of 19830 PCH, where even the Army Corps of Engineers couldn't figure out how to get down on the beach to do debris removal, and they opted to do it from up above. So I think in those cases, even just hand dug pits, or I don't know. Sometimes I keep thinking you just need to get one person, one group, and do geophysical lines. We want to know that you've thought about the various ways. And Mark is dealing with that on another project where there's a house there and they would have to crane over, and they were willing to do that, but I think they figured out another way to do it using existing information, I think, based on pile observations. So in that case, you could go back and find pile observation reports, maybe, if there were, So I think we're open to, if you can't get drilling access on the beach, that would be the kind of thing where we would expect, if you wanted to, come in and discuss it with us and go, hey, we're talking about using this information, and here's why it makes sense to us. If you want some preliminary commentary, or you can just put that in your report.
That brings, and this is my lack of experience on beachfront properties, but how much, we have beach sand sitting over bedrock, which is the majority of the cases, albeit deeper in some areas than other. What is the liquefaction variability of that beach sand? In other words, is there a way to say, like, look, there's 20 feet of beach sand, this stuff's all going to settle 4 inches, 8 inches, and we design the piles accordingly without having to drill? I guess that's what my question is. How much variability?
I think you could go figure that out, maybe, if you go and look at a bunch of different reports. And here's something where we can help you. I know that individually you can only download one report at a time from OnBase. Is that correct? We can download whole swaths of geotechnical reports. So if you're working in the 20,000 block and you want, in fact, we've already done it. In fact, we probably should just make these reports available somewhere, stick them out on a Dropbox, where every single geotechnical report that's been done, right? And then there are also other sources like the PCH characterization report that was done by Caltrans, all of State Route 1. I think we've provided that in our resources link.
Well, that's like music to our ears. That's wonderful. If we could get a Dropbox access to all that.
Sure, we can do that. Easy enough. So you would end up then needing to do a statistical analysis or looking at it yourself and providing examples and going, hey, But then there's also more recent reports which in the past we are making a very big concerted effort to make sure that the reports, as they come in and get reviewed, get posted in OnBase so that there's no lag time, so that you can get all the most recent information too.
I recently read a geotech report for a beachfront property, and I believe they had difficulty getting drill rig access onto the beach, and they'd done some drilling from the road, had not even really reached the depth of the beach in their drilling, and they had not tagged any bedrock, and they did not really discuss bedrock or make recommendations for foundations founded in bedrock. And it may be a bit of a newbie question for me to ask, but is there a general guideline applicable to the investigations on the beach that says you must either find the bedrock or discuss the depth of bedrock of surrounding properties?
If bedrock is where you're going to put your foundations, I would think good engineering practice would dictate that you would have some basis for that.
In this case, the recommendation was not to found the foundations into bedrock. It was...
Okay, then they'll have to justify the stability of the material that they're recommending it be founded in. Particularly if there's a, is there a heavy drop-off?
I can't say, but
okay.
It's...
Well, it's a hypothetical, and we're here to deal. That's not anything that we can answer. Then we just review the report and see. We'll review it on its merits.
Yes, we have a question online from Alexander Green. All right, Alex, we're going to unmute you.
Yeah, thank you for bringing up this topic of liquefaction analyses. And my question, might be able to be answered by someone with a little more experience. But when it comes to these beachfront properties, what is a liquefaction analysis really telling us when the end design that we recommend as the geologist is going to be friction piles that end up in bedrock? From our perspective, we should be able to provide sort of an assumed down drag value on those piles. And in that instance, when the residence is founded on bedrock, liquefaction becomes a bit of a moot point.
I don't think it's a moot point when you're trying to evaluate whether there's going to be lateral spread or not. And the other thing we're curious about is if the beach sand extends under PCH, if it happens to be a site where you've got an embankment. And I think it's standard engineering practice. Also, too, with the new version of CLIC, which was put out, they have the ability to look at better define the water pressures and the exit pressures and whether you exceed the uplift capacity of the overhead burden and tell you whether really you're going to have a loss of strength or not, which is a good indication of whether you're going to have any lateral spread. But I see your point. You're not the only one that's brought this up. I've had this discussion with at least 2 other engineers who said that they didn't think they needed to do drilling on the beach, and they were just going to assume that everything liquefied below. I don't know how they were going to handle the dry sand. I mean, you can submit the report and the analysis and we'll look at it. And if you want to have a meeting about it, we can discuss it. Is that satisfactory or no?
I think that's satisfactory in the sense that we'll provide something. Ultimately, it's a structural engineering question too, because if it's not, if they don't get, we don't care if it liquefies or doesn't liquefy. So hopefully we'll have a structural engineer that'll say that, and then we don't even have to do the analysis.
I think it's a matter of if the construction budget allows for a super conservative design, then I think you're almost making the prescriptive decision, right? This is going to liquefy. We're going to have this much down drag. If the budget and the construction can handle it, I don't have an objection to that approach.
So I'm just kind of thinking out loud here. You know, for years we've done creep forces, you know, outside of liquefaction area, but we do, you know, 1,000 pounds per foot creep force on a pile. No one seems to question it. Structural engineers never say, "Oh, you're giving me all these creep forces. I can't design it." So, is there somehow we could come up with a value like that for these beachfront properties where the bedrock is not super deep, you know, 10 or 20 feet?
Here's where I'm going to go. I'm going to go back to the section of the code that requires both LA County code and then the building code, right, that requires reports that address liquefaction. And then you go to what are the standards of care, standards of practice for doing a liquefaction analysis, right? And I think you just have to step your way through that. And that's basically for any report that we get that does not have any information on that site specifically or reasonably nearby that can be interpolated to be representative, we're going to have to just go take a hard look at what the geotechnical practice is, right? We're not trying to change the practice here. So if somebody smarter than me wants to come up with a way to characterize that load and just have something standardized, you know, that meets certain criteria but it's all sand grain dependent, right? Grain size dependent, depth dependent, water table dependent, a bunch of different site characteristics that I think that go into that. I don't know, we can have a discussion about that if you want. You can propose something to SCEC.
Right, but it may be as simple as saying, water level is 5 feet above zero. Shenandoah is saying the structural engineer is going to assume that it all has lateral spread to it. And they've said that whether it goes 2 inches or 10 inches, I guess that was my first question, was like, what is I don't have the experience, but there can't be that much variability in crappy beach sand loaded with water liquefying. I mean, if I said, oh, my blow count showed it's 1.5 inches under an event, and you're like, it's 15, I mean, there's got to be some range of reality here.
Right. That's why I offered. I haven't done that study myself, so that's why I offered to just we'll just give you all the downloaded reports and you can go look. I will tell you one of the more recent reports that we've looked at, it was 1.5 inches. Groundwater was at 5 feet. Sand was about 20 feet. They had gravel and cobbles right at the bottom of the sand layer. That wasn't going to liquefy. And then they had some dry sand settlement above that.
Do you guys have any questions about the required findings under the code sections? They're here or online. The reason I asked that is because to me the section 110 of the code, LA County, was sort of a roadmap for a lot of these circumstances with homes that were built on landslides that went unrecognized, and they, some of the stuff has been in the code for 30, 40 years or more. But the other day I looked at some draft geotechnical reports for some sites in Big Rock, and the consultant made section 111 statements that the site was not subject to landslide settlement or slippage. And we had a discussion about that, and I let him know that these rebuilds are under section 110, geotechnical hazard area, and that you need to make the findings that are required in 110.2.1 instead. And then he had an aha moment. So I just want to make sure that you guys are clear on that stuff.
How does that differ? What does it say? Like the house is gonna experience movement, the owner just assumes risk?
Well, I mean, and my experience has been reviewing all these years is that people think that 111 has to be written in a positive sense. But what if you can't make that finding? What if your site is subject to landslide? Well, that's why this other code section exists. So 110.2.1, what we need to know is whether the property outside the site of the proposed work could be damaged by activation or acceleration of a geotechnically hazardous condition. And that activation or acceleration could be attributed to the work you're doing on the site. So it's similar, make sure you're not creating an offsite hazard with this rebuild. Similar to the findings required in 111, but it's everything we're looking at that's in a mapped landslide area, whether it's been historically active or not, I doubt most of those are going to be considered stable with factor safety greater than 1.5. So they're all falling in this geotechnical hazard category, and they're primarily falling under 110.2.3.6 unless you're in a circumstance where you might be able to mitigate the hazard with the rebuild. Could be some small shallow landslide that could be mitigated with grading or structural elements or something. Does that make sense?
It does, and that's very helpful because, I always thought a 111 statement is I just had to throw them into my county and my Malibu reports. I mean, I don't have to do them in LA or Santa, other municipalities. So
I think it's just one of those things where we want you to read the code, right? For a lot of the stuff up on Big Rock Mesa, it's very code driven. And so you just read what the code requires and provide a description of that. Ultimately, it's a matter of, one, making sure you're not changing the risk or exacerbating the hazard, and two, that the site is safe for its intended use, right? It's not going to fall down and kill somebody.
Yeah, so I'm expecting to see, modified 111 statements, really. about what can happen. The Big Rock Mesa landslide has experienced small amounts of creep in the wettest rainfall years, going back to 2005, 1998. And so if I were writing a report up there, I would be saying that that's what could happen is, and it's all a function of groundwater levels and whether those are kept at bay, which is a function of the assessment district and yada, yada. It goes on, there's a bunch of factors, but at the end of the day, if I'm writing this report, I would say, it is subject to creep in the future should groundwater levels rise above certain critical thresholds. And that's the risk that you're stating to the property owner, and that's the risk that they are then assuming via that legal document that gets recorded. Yeah. Oh yeah, my favorite subject, the fault subject. So I heard the comments earlier about I guess we need to talk a little about evolution of fault study requirements in Malibu from the moment the city became a city. And I'm going to go from my recollection, but not long before the city incorporated, the county had updated their seismic safety element. And it basically defined all of the same fault traces that Tryman defined in the 1994 FER a few years later. And they actually stated that all of these fault splays should, the seismic safety element stated that these fault splays should be treated as active unless proven otherwise. And so when I think probably Don Kowaleski writing early guidelines for the city as the first city geologist, and myself and other people, and I think it made it into the general plan safety element, the first general plan safety element of Malibu that way as well. That input came from a geologist named Dennis Hannon. Anyhow, the point is, or the question is, we now have one AP zone in Malibu as a result of Tryman's FER. And he evaluated this whole thing for the criteria of sufficiently active and well-defined. We only ended up with one zone. There were two, but one of them got removed. So I've been wondering whether that means that these faults have been proven otherwise. They didn't meet the state's criteria of being sufficiently active and well-defined. And I've asked myself, why are we still requiring this? Is this onerous? Because we have some other information that has come in very recently over on the west side of town that involves the Escondido thrust fault, which is one of those faults in Tryman's map. And there's been some really good evidence showing that it's got to be, last movement was older than 200,000 years. So, I look at that and I say that fault could be completely taken off of any map in terms of should we consider it active or not. So this is a topic for another day, I think, because we want to have, I want to have this conversation with the people at the city and talk about the history of, how this came to be. I also don't want to create an onerous situation. There's some impossibilities in some places to evaluate these faults. I understand that. And my attitude is give us the best information that you have. I don't know that you necessarily going to have to go do a row of borings or CPTs to prove that there's no faults underneath a beach site, because that would seem to be pretty extreme. It's impossible to drill on the beach in so many of these places. Yeah. Yeah, the soils aren't going to cooperate, yeah. So I don't want to send you on a wild goose chase to come up with something that's going to be age undetermined at the end of the day. So, you know, there's been questions, a lot of questions came out of the Woolsey fire about building footprint. And, you know, do I just need to cover the building footprint? Do I need to go 50 feet beyond that? I think that we're leaving that to your discretion. I mean, a lesser setback, you know, the AP Act reads 50 feet, but we will consider, if you can't study an area or it's just impossible, or the soils aren't going to cooperate because, you know, you might find a fault, but you don't know how old it is. We're certainly going to consider alternative setbacks, lesser setbacks. Yeah. Yeah, if you're within the same footprint.
Within 5 feet on either side.
Yeah. Yeah, but some of these could shift tens of feet. The building footprint could shift and still be considered like for like.
People proposing ADUs. Under the governor's order, right, ADUs are not requiring to go through feasibility. But if you're putting that on a site that is within 500 feet of the Malibu Coast Fault, unless that site is cleared by another investigation that concluded that there was nothing there, you may run into an issue. Fortunately, I think most of this is in areas where there's not going to be room for an ADU. But we did have one north side of La Costa Beach on PCH. It was a multi-unit, and they wanted to add another unit, and they wanted to add it north of the property. If they had added it within the building shadow, then they would not have been changing the risk, right, that site was exposed to. But they wanted to add it north, right? And so that was problematic.
I appreciate you brought up the ADU thing because everybody wants ADUs anymore. So it sounds to me like with the like for like, they can do an ADU and still consider it like for like if it's within the same general region of where the existing house is. Or are you going to be addressing the ADU as new construction? Because the definition you gave there just seemed a little nebulous to me.
Well, from a construction standpoint, from a foundation investigation standpoint, you need to provide some information, right? If you don't have existing data, that's a new structure. You're going to need to provide some justification for your foundation design if you don't have it for the main house already.
Yeah,
but I'm talking about with respect to the fault, you know, generally speaking, these faults run east-west, right, for the most part. So if you've got a structure that's running north-south already, and you're going to add new construction next to it from a building code standpoint, that has to meet all the requirements, right? But from a fault investigation standpoint, I think you could say, hey, look, we're not increasing the risk here. We can't, you know, we're not going to be able to do a fault investigation because there's no soil that's left there that's going to date this. And then the other thing is go to the Tryman map descriptions of the nearest locations, right? Because that's kind of where that's where we were trying to go with the one fault investigation that Mark had, which was on the beach. And we were trying to go with the closest descriptions of Tryman, you know, observations of the nearest locales. So basically, you got to do a deep dive into all the existing information.
I believe Alexander has a question.
Alex, just come visit us.
Alex.
Yeah, so again, glad hearing your opinions on this, Mike and Lauren. So it does sound like you guys are in agreement that these guidelines do need to be modified, and we're of course happy to kind of give our input on that when the time comes, and maybe another roundtable discussion will help modify these fault investigation guidelines. But when it comes to these fire rebuilds with virtually none of these sites on the coast and that are on the Tri-Men map, the faults being on the Tri-Men map being in a current AP zone, how's the risk actually being increased if the current knowledge of zones is that these faults aren't actually active?
That's correct.
Not increasing. It's
Can you use your microphone so the other geotechnical engineers can hear
Yeah,
you?
the risk was the same before the fire as it is after the fire if there's a fault under there. Nothing changes.
Yeah, I guess that's not really my question. It's more of, I guess, getting at these guidelines needing to be updated because, since most of these aren't within an AP zone, the risk of surface fault rupture is not there because these faults are bedrock faults that are way older than the Pleistocene.
Are you talking about with respect to the fire rebuilds, or are we talking about the general guidelines?
I think it would be a combination of the two. We know we have one client in particular who, did in adjusting the footprint for a fire rebuild want to because of the cost prohibitive nature of a fault investigation, even though their site is not within an AP fault zone.
Oh, this is probably the one then that where they're proposing an ADU or additional structure north and outside of the building shadow?
Yeah, maybe so. Yeah, I think so. I can't
think
remember
it's
if it was
probably
a
the same
primary
site.
structure or if it was CAB.
Right. Okay, well, so maybe you can't build an ADU without the primary structure, so maybe there's enough time to deal with it. And they'll deal with the primary structure first and then the ADU after.
Okay. Yeah, and again, we'd love to be a part of those discussions if these guidelines do get revised.
Absolutely. Absolutely. We plan to cast a wide net. A lot of you have expressed that desire.
Yeah, but the topic of fault surface rupture hazard needs to be addressed or revisited, I think, in the complete geotechnical guidelines for the city. That's something that we're going to be doing.
I think just for my homeowners that might hear this conversation, this will not delay any of the reports. This will not, their geotechnical consultants will not need to wait for the city for anything. I just want to make that clear.
That is correct. That is correct. There are other ways to deal with this. So no, it's not going to delay their fire rebuilds. Yeah, make it very clear that any of the discussion that we are having right now about faults or revisiting the guidelines, the geotechnical guidelines with respect to fault evaluation, are not going to delay the fire rebuilds. They're not going to have a significant impact.
If any of the geotechnical engineer, geologists have any questions, please visit the Rebuild Center to make sure we give you the guidance that you need to complete your reports. Right now, that a clarification on our guidelines are still coming forward.
Right. Any clarification on the fire rebuild guidelines will happen very quickly. What we're talking about is a broader topic. The way that the fault issue can be handled for fire rebuilds is through an assumption of risk and release. So there is a shortcut way that is allowable and easy to do and doesn't require any additional investigation.
Just requires you to describe the potential risk.
Thank you. And with that is 1:53. Any more questions? We thank everybody that joined us. This session will be recorded and we will post it on our website. Thank you.
Especially for showing up in person. We appreciate that. Thanks for making the time.